Today, we will be working on the what we call AIS data sessions. So my name is Marky Muryawan. So I am from UN Statistics Divisions, and we have my colleague here, Gabriel and Alex, that are in person. So today, we will, in the morning, we will have presentations and demo. So there is no coding required in the morning. So you can just follow the presentations. And if you have questions for in-person participants, you can raise your hand, or for a virtual participants, you can raise your virtual hand, and then, or you can also go to post your question in the chat. So all of the presentation and codes, we have upload them into a share folder, right? It's also available from Slack channel. I already posted the link to the Slack channel, and you are welcome to join. Okay, let's start. So my presentations will be to give you a brief overview who we are as an AIS Task Team, and what are our program for this year and forthcoming years. So there will be more and more information about what is AIS, but I will just give you a brief explanations. So AIS is basically an automatic identification system, which was not exactly it's not exactly clear what it is, because everything can be an automatic identification system. But you have to remember that AIS, it was designed back in 2004, right? So at that time, there was no automatic identification system. So now the AIS always refer basically identification system to track ships, right? And it's not exactly only ships, right? So any mobile equipments on the sea or inland waterway. As I mentioned, so it was developed in 2004 by UN organizations called IMO, International Maritime Organizations. The intentions is to avoid collisions, right? So the ships has to broadcast their positions, right, and certain informations, so that the ships surrounding them, they know there's another ships. And then the idea is to avoid collisions. And of course, fast forward to 2022, now, this information is not only useful for avoiding collisions in the sea, but it's also useful for many things. And we are going to learn more and more about this. So how it works, so the ships will transmit their AIS signals, and it will be captured by either terrestrial stations or satellite networks. And then they will be aggregated, right, by aggregator, we call it a maritime data aggregator. And then we, as the AIS data users, we can use it. So the afternoon sessions basically is on the end. So will be using our computer to query these data sets that have been collected, in real time, basically. So I mentioned earlier that we are an AIS Task Team. So what is exactly we are? So we are part of UN Committee of Experts on Big Data and Data Science for Official Statistics, right? So we are not the only task team. We have a mobile phone task team, right? We have a privacy preserving technique task team, and many things. But the idea is just to explore the big data and the data science for the official statistics. So we are all under what we call UN Statistical Commission. So this is the highest body, intergovernmental body that basically overseeing the activities and program of statistics. And then under the committee, so we have this AIS Task Team, that we are AIS Task Team, and we have some other colleagues in AIS Task Team. And my next slide will show you who exactly we are. We also, at the same time, there is something what we call UN Global Platform. So this is a platform that are intended for all of you. So all of you can have access for free. And you can access to the data that we have. You can also access to the computing power that we have, right? So if you want to run certain complex calculations and your laptop is too slow, so you can use this platform, right? And again, it's free. At the same time also, there is another committee on experts on business and trade statistics. So because AIS can be also useful to forecast trade, right? So these activities on the business and trade statistics, they are also actively working with us, especially that they are engaging with the trade statistics revisions. The manual on the trade statistics. So we are also working not only on the data sides, but we're also working with the substantive sides. And of course, trade is only one applications on AIS. Later on, here in our workshop, so we will looking closely on the use case of basically a port efficiencies, like a port calls, like time spent in ports, and we will also we're going to working on the calculation of maritime emissions, because all of the ships, they emit emissions, right? And then with AIS and with certain modeling, we are able to calculate how many CO2, for example, they release. Gabriel will be showing us on this. So this is just a list of the memberships. So we have a statistical agencies, right? We have international agencies, and we have others. Others is mostly is a private and academia. The membership is open, right? All of you, if you are interested, you can join. You will learn from each other, right? Everyone have a different projects. So we meet usually virtually every month, right? We share informations and then we have a question and answers, and then we can also share some experience and so on. So basically you can see that all international organizations that related with the transportations, they are there, right? Especially, I think we have this IMO, for example, which is I mentioned earlier that they initiated the specification of AIS back in 2004. So this is just a go through of the recent development that what we have done so far. So in addition to regular meetings, so we also have the increase team size. In the beginning, it was like only few of us. Right now, we have more and more. We do have an AIS handbook. So if you want to read through what is AIS, so we have an AIS wiki, basically, that we updated regularly. We also recently updated our platform that enable better user experience and scalability. So we also released the foundation AIS e-learning course. So you are welcome also to join of this course. We also acquired the ship register. So remember, AIS is a tracking, right? In specific ships, where are the locations? But if you want to know the owner or the operator of these ships, you need another data set. This is what we call ships register. If you want to know the engine, when the engine was built, there is no information in AIS, right? But they have information in ships register. So we have around 100,000 ships registers information in there. And it can be used for many things. I mentioned earlier about these maritime emissions. In order to do that, in addition to the speed, right, you need to know what engine they use, because different engine will emit different emissions. We also have a plan to develop AIS curriculum, so I will mention it later in my slide. So we also participated or contributed to the UN Youth Hackathon, basically 1 month ago. And we have some kind of like joint activities with other group, right? So one of the most important thing is this UN ECE and UK ONS on the machine learning group. So this year we have a specific joint program to identify port areas using machine learning. And we also have relations with the UN log code. So this group is the one that is defined the codifications of ports and any terminals. And we're also working with them. some completed projects from our task team. So IMF and University of Oxford, they release a paper on the tracking trade from space. So they focus on countries in South Pacific, right? But the methodology could be applied anywhere. The UK FCDO, also they have a project on the monitoring port efficiency in East Africa. And what is the project for this year? So we have an ongoing project on the proof of concept on the maritime transports with the CSO Ireland. This is a Central Statistical Office of Ireland. So we have a ongoing work with MTCC Latin America to monitor a Panama Canal and also the emissions. We will also develop 3 new e-learning courses this year. So remember that we have a foundations, but now we want to go for more advanced, more intermediates for certain calculations. So AIS also part of these research topics on the trade revisions manual, as I mentioned earlier. And we will have a work with the ML group to automate the port and on berth detections. And we do plan for a global AIS hackathon this year. So last year, we didn't have it because we are part of the UN Youth Hackathon. So we conducted the first hackathon back in 2020, right? So we had a very good participations. So now this year, we would like to conduct also the second one, most probably sometime, in September. So this is the winner of the 2020 AIS Hackathon. So it's a blue carbon group. So they are basically calculating the emissions and they map it, the whole world. So you can see that a lot of emission in certain busy area. Right? And when we talk about sustainable development goals, of course, anything about environment is very important. Right? And AIS is one of the data sets that can give you a global overview on the emissions. If you are from statistical office, it's almost impossible for you to calculate water emissions, maritime emissions. Even if you send a questionnaires to the operators, right, they may not be able to calculate emissions. Whereas with AIS, we don't need them, right? We just run our modeling and we will get something. So finally, this is our curriculum on the big data. So, so we have developed this, what we call a core curriculum. So if you want to be, a good data scientist, so this is basically the courses that you have to follow, right? So for example, as a intermediate or a foundations, you need to know Python, right? And then you need to know PySpark, you need to know SQL, you need to know a good coding practices. You need to know at least the introduction to the machine learning. I mean, yesterday we had this very good overview on the machine learning, right? So this is part of the curriculum. You need something for the disseminations and so on. So this is a generic, not exactly AIS, right? So this is basically if you want to go to data science, you follow this. Simple, that's it. But if you want to focus on AIS, so we have another one that is really focusing on AIS, right? So we can, for example, you need to know how to extract the data from the platform, right? You need to know how to link this AIS with the other data sources. You need to know how to develop the economic indicators, maritime emissions, right? Fisheries and so on. So, and these use cases will be developing, and there will be more and more of this. So, why we use AIS? The reason is simple. AIS has been there for some time, and there is a general availability of these data sets globally. Right? So, one of the challenges in the big data usually is access to the data itself. Right? If for example, social media, there are a lot of information in social media, but you may not have access to this. And getting access is not easy, right? Whereas in AIS, you have it already in the platform. So you don't need to do anything. What you need to do is to learn, some basic of data science, and also understanding on how AIS works. And the second is there is no perception of privacy issues. If you look at the mobile data, people will complain, oh, privacy here, right? If you look at AIS, it's basically this is open data sets. If you have a radius receiver, you can capture AIS data. I mean, you can go to Jabal Ali, use your radio transceiver. You will get some AIS signals because this signals is basically a radio signal, so it's open, right? So basically, almost there is no privacy issue. Maybe in certain situation there is an issue, but in general, this data sets is open, right? So you have it in the platform and no privacy. So this make AIS is attractive to explore and to use, right? The only challenge is really use cases. What do you need this for, right? And this is something that we're going to discuss. And the second is the knowledge, how you access this. Because AIS is a relatively big data sets, right? So there is like around 1 million or I think 1.5 million messages per second or per hour. So there's a lot of these messages. And you cannot use your only laptop. And even if you have a lot of big servers, it's always a challenge to put these informations in your servers. That's why we developed this, what we call this global platform, so that the data is there, is regularly updated, and you can just need to use it. So if you follow the afternoon coding sessions, I will guarantee you that you can access information. You can calculate if you are from, I don't know what, yeah, if you are from a country, right? You have a port. If you can identify the position of your port, after our coding session in the afternoon, you can calculate how many ships coming to your port per day. And then you can just run this algorithm, forever if you want, right? This is the basic. Counting ship is the basics. Okay, that's it. I hope I don't take too long. So I don't know if you have a questions in person. Otherwise, I will be around in here. Okay. So from the online, we have questions. What are the requirements to have access to big data curriculum? So the big data curriculum is just a design, right? So it's just a curriculum. Maybe your questions may be access to the e-learning courses, right? So we have only one e-learning courses, which is the foundation courses. I will post the link now on the chat, on the Zoom chat, and it's also some access code so you can go through this. Later on, when we develop 3 new courses, so this is basically a free access. There is no requirement, right? And then of course at the end you will get some kind of like a certificate if you pass the test and so on. So there is a question on the age group. So there is no age group, right? Yeah, anyone can go to this, and there is no background, whether public, academic, students, wherever this is, your statisticians, your data scientists, you can go to. If you are interested and you are willing to learn, you can go through this. So we have a questions again. What statistical indicators can be derived from AIS platform as part of the maritime transportations? So traditionally, AIS is really used for maritime transport, right? Traditionally, for indicators on maritime transport. So we will have some use cases later by Cheryl virtually later on that focus on the on the maritime transport. So we can have port calls, right? Time spent in port. We can also calculating the routes of the ships. We can also calculate the efficiencies, or we can identify the trading routes, and so on. But something that is interesting is go beyond maritime, right? So this is like trade, for example. And some colleagues have used AIS to forecast trade because they will know when the ship will be coming to your port, long before it's entering your territory or long before there is a custom declarations, right? So this is something that's interesting. And if you follow the e-learning courses, so we also explain all of these use cases, right? And another example is cruise tourism, right? So in Caribbean, for example, there's a lot of the big cruise ships that going around Caribbean countries, and we can track them. And that can be also useful for travel statistics, for example, or tourism statistics, right? So this is another use cases that we can think of. So there are many cases of the use of AIS. There is no limit on our imagination what we want to do. Later on, if we can link the AIS with other data sources, for example, customs, so we will know better information, what kind of goods are in these specific ships, right? And so on. Yes, go ahead. I don't know if there's a second mic or there's only one mic.
Thank you. What if the system is switched off? Because this will create a problem of representativity. What if this system AIS inside the chip is switched off? So there is no signal.
Oh, yes. Thank you. It's a very good question. So the question is that what if the AIS transporter is switched off by the captain of the ships? Yes, it's possible. However, it's in violations of the IMO regulations. However, with machine learning, we can track when the ships is switching off the transponder, right? Because if you have some kind like a tracking and then suddenly it's going dark, this is what's called going dark. So we will know them and then they will be on again sometime. And in certain ports, there are strict regulations, right? So if you want to go to a specific port, you have to turn on the AIS. Right? In high sea, maybe you turn it off, but again, this is against the regulations. But this is part of the limitation. So in e-learning courses, we also talk about limitation. Another limitation is human error, for example, right? Another limitation is because this is a radio signal, it can be corrupted and so on. And there's many things. This is part of our what we call data preparation, right? So when we analyze the data, we have to take into account all of these issues. And we will show you how to do this. So we have another questions. Is the AIS is open to the public and does it has an API? So AIS database is inside a UN global platform, right? So they have an access. So when you say open, so a public is possible to have access, but you have to request, and then depending on your use cases, right? Why do you want to use this, right? So we may grant it. This is to the general public, but if it's from government institutions, right? Whether it's statistical office, customs, port authority, you have immediately granted access. But if it's someone from academia, for example, that would like to access, we have to be careful because this platform is not free. Yeah? I mean, it's free for you, but we have to pay. So if we are starting to give a free access to everyone, right? So we may not be able to cover the cost because this platform is really intended for our counterpart, right? To explore the big data and data science. So public is possible because we do have some public that accessing academia, for example, or researchers that accessing our database, but this is a case-by-case basis. Yeah. And of course, just like Gabriel mentioned on the chat, so you can also access the AIS data sets from the commercial provider, right? For example, marine traffic, exact Earth, fleet monitor, and so on. So you have these informations. But what we have in the platform is a raw AIS data sets, right? It's really messages of AIS messages from the ships. Okay, so I hope that you are sold, that that you know that AIS is important. And we have another 2 presentations from Alex. So Alex will make presentations on the platform itself, right? And then we will have presentation from Gabriel on the AIS, the content of AIS. If you have any questions, use Zooms. If you're in person, raise your hand, or we can also chat during the break. Ready?
Okay, hello everyone. I'm Alex Neubert. Perhaps some of you remember me from yesterday's machine learning session, if you have been here or joining online. Just a second to share my screen so you can see my slides. I work in data science campus in ONS in UK, and I have been involved in creation or running of this system for quite some time now. So today I'm going to talk about the more technical details behind the platform, some design decisions, and how it's working under the hood. So my slides are available now, and we're ready to go. Quick overview of my talk today. So AIS is a big data, and I'll explain this in more detail in next slides. Of course, a lot of people talk about big data, but I'll explain exactly what I mean. Also, AIS is a geospatial data. So I have more slides on this, but ships move around and they transmit a lot of information, but most essentially, this is so-called dynamic information that they transmit. This is mainly their coordinates, depending on the frequency update, but most likely a few minutes you'll see updates from the bigger ships at least. And then, because it's a big and geospatial data or geospatial big data, then we had to design a system that is able to cope with these requirements coming from the size and the specificity of the data. And I'll explain in my talk how we designed the system and how it's working. Then how we optimize the system to minimize costs. Of course, cost is always important decision. And how we used geospatial libraries and Uber's hexagonal hierarchical spatial index. I have more slides on this. Okay, so for the next thing, why it's a big data? It has big size, and it's coming live to us from our data provider, which is Exact Earth through API. I have slides for this as well to explain more. One of the biggest challenges with the big data is analyzing it, because first of its size, and then it's quite messy. There is a lot of noise that needs to be cleared. The data needs to be cleaned. Also, there is a problem with the raw AIS data that sometimes there are conflicting messages. So imagine a ship transmits their position, but it's captured by two stations. So either ground stations or, in our case, satellite, one of the 65 satellites of our data provider. And then these two messages come at slightly different times, so there is a conflict between these messages. And of course, this has to be resolved. And luckily for us, the algorithms have been implemented by our service provider, our data service provider that do this for us, and we receive relatively clean data, so don't have to worry too much about the conflicting messages. Of course, some further data processing is done by us, checking for duplications and so on. But compared with the raw data noise and problems and messiness, this is a negligible amount of data processing that we introduce later on in the process. So how we cater for the big data? We are talking about terabytes of data here, maybe 40, 50 terabytes of data currently. And everyone who's tried to process such amounts of data on their relatively good computer knows that it takes ages and possibly cannot be done on time. Imagine that it's not only you trying to process this data, probably it's currently 100 people at some peak times working on the system. So if 100 people try to use your computer, it will get even slower processing this 40, 50 terabytes of data. That's why we focused our attention to distributed processing of this. So instead of having one computer with, if it's a could spec computer probably, I don't know, 32 cores. We can acquire resources, compute resources on demand. With the previous system that we used about a year ago, and the problem was that we couldn't scale up the system when demand was growing, and people had to queue and wait for the resources to become available. But after the redesign since last was it April or May last year, when a new person, extra user comes to use the system, then we're using cloud, AWS cloud. Additional resources are required, and this user can start using them immediately. Of course, we don't want to keep these resources when the user finish their job and stop using the system. Then we release them, and because of the payment business model, we're paying by second. So as soon as we release the resource, it's no longer billed to us. So this is how we're doing it. And of course, it's not that easy just to acquire computers, instances, virtual instances, virtual machines in our case, and use them. You have to have the infrastructure and software framework that allows you to do distributed processing. So for this purpose, after some research, we identified that Apache Spark, I have more details in the next slides, is a suitable system. And I'll explain more a bit later. Again, scalability, very, very important for us, because if the system is not scalable, we won't be able to fit to the demand. We cannot answer the demand requirements that easily. So imagine on the weekend, there is almost nobody interested to compute where their ships are or how many ships are coming into the airports. And this means that we don't need any computers, and the system scales down to a minimum resources required just to keep the core. It's called Spark driver in our case, and it's like coordinator that coordinates the work of the distributed resources. When the people come back on Monday, there is a lot of people eager to use the system, and it gets up to hundreds, if not thousands, machines if possible. And today, this afternoon, actually, we'll do a very interesting experiment when we will release API keys and ask everyone who is involved here and has computer to do small computation exercise, and we'll see how the system copes by the demand of the users currently on this call, or this afternoon on the call. There is additional advantages of distributed processing, and this is increased reliability through redundancy. So imagine we have these 100 virtual machines running, and something happens. Not that it happens very often, but theoretically it can happen that a machine fails, something happens. So because we're also using spot instances, it may be taken away from our cluster at any time. So because of Spark features, it's catered for. So if one of these machines is taken, of course, some of the data will be there on this distributed node, and some of the computation will be lost. But the system tracks what has been computed, and if something disappears, like a resource, like a node in the cluster, it goes back to the last checkpoint and recomputes what is missing and recovers gracefully from this failure. So the user probably will see some small delay, which probably will mean waiting for a few more minutes. But in the end of the day, their job will finish successfully, and they wouldn't notice much else. So this is increased reliability through redundancy. We are not concerned if any of these computers fails or it's taken away for some reason from our cluster. The system recovers gracefully. Of course, there are some disadvantages of using distributed computing. If you've done normal Python or any other programming language, it's one style of programming. And when you switch to distributed processing, you have slightly increased software complexity to worry about. But this is not that much of a learning curve because there is a good documentation. We provide training materials, and also we have example notebooks, example software code, which we share among our community, and everyone is quite friendly and ready to help you out if you get stuck with some of the intricate details of the distributed software computing and programming. Also, if you task with creating a cluster from scratch, even if you are very well seasoned, let's say, system administrator, perhaps first time it's a bit daunting task because there is a lot of configuration of the cluster. You have to think about resources, how much memory for each node, how they work together, how they talk with each other, how they report to the coordinator, which is not easy task. So configuration of a cluster is not an easy task, but the good thing is that by joining UN Global System AIS Platform that we provide, all these difficulties and complexities around configuration are taken away from you because the system is run by us and our partner Data Mechanics. And you only have to write your software and to submit it as a job to the system. From there on, it's not your concern how the resources are distributed, how the resources are provisioned. So everything under the hood is our worry, and so far it's been running relatively reliably and robustly. So we can claim that it's quite a good stable system. Moving on. So this is what I was telling earlier, that the UNGP AIS platform, our platform, is designed to offer the advantages of distributed computation for everyone who is joining, while lowering the entry barrier. So, of course, if you can imagine that system of 20 big computers cost money, quite a lot of money. But because of the optimizations that we have in the system and this automatic scaling up and down of the resources, the nodes being acquired and released on demand, we are quite sure that we're using the resources quite optimally and getting probably a good deal from our back. Also, the system is built on open source tools, which means that there is no license fees and nothing to pay, royalties to pay to providers. So this is, I have more slides on this, but this is, as I said earlier, Apache Spark, which is of course open source. We're using Kubernetes, which is also open source system. This is under the hood, and many other open source libraries for geospatial processing of data. Scalability, as I said earlier, the platform obtains compute resources. Of course, there is a small delay when a user submits a job and the system currently doesn't have the required resources. It takes 1 or 2 minutes, perhaps, in most cases, and the resources are acquired, provisioned, and the job starts running after this. So for this small delay, the plus side, the benefit is that we don't have to pay the resources for all the time when we're not using them. They are paid only when they're required. Community support, we have a nice community in AIS Task Team, and people are quite helpful. Everyone is happy to provide their code, their experience. If you're stuck with some problem, somebody will come back and tell you a few suggestions, give you a few suggestions for you to try and work out your problems. And also we are currently working on a new version of the system, new version of the storage format, which actually will provide extra benefits in terms of indexing, and I have slides on this later on. So I mentioned Apache Spark as a key element of our platform. Quick idea for people who are not familiar with Apache Spark. So this, as I said, is a distributed system. It has a cluster manager. You see this box in the middle, white box in the middle of the slide. And this cluster manager is coordinating the work of the worker nodes, which could be normally from 3 up to thousands sometimes. And the job is split between these workers. And that's why we get the speed up from computation. So imagine your computer is equivalent of one of these worker nodes, and it's doing the job when some job has to be done, it's doing it sequentially. So until it's finished, this task and the next task. Of course, if it's a multi-CPU computer, there might be some prioritization, but this is limited to the number of CPUs that are in the computer. With this system, the scalability is almost linear, so the time for computation doesn't grow with the number of worker nodes. So when we have a big job, simply we acquire more worker nodes, and they are computed in parallel. Of course, saying this depends on the operations. Some operations, like summation, can be done in parallel, but there are some operations, perhaps a bit more complicated machine learning operations that require the output of the previous task, previous stage of the job in Apache Spark jargon, to be able to start the next tasks. So this is a bit more tricky, but 80% of the work can be parallelized, and this allows very big speed ups. Moving on, geospatial data. So this is the second feature of AIS data. In fact, AIS data is not unique in this space. Also imagine in transport, for example, if you are having a fleet of vehicles, buses, lorries, trucks, anything, this can be tracked by GPS trackers and transponders, and we have the similar problem that we have location information with the same characteristics of these data sets. We have attribute information, which in our case are some identifiers, the MMSI number. I'm sure my colleagues will talk about this later. Additional information about the ships, like name of the ship, destination, and other. Draft, so this is how deep the ship is in the water, and many other fields in the data set. And finally, last but not least, we have also temporal information. So the information is time-stamped. The moment the message is sent by the ship or received by the receiver, it's time-stamped, so we know when the message has been sent, and we can put them together. So this makes the data set time series data set. So we have a sequence of messages and progress of the ship. So these are the three properties of AIS, and taking this property into account, the system is designed to be able to optimize the computation based on these properties. And I'll give an example here. The location information, this we have to keep in mind that this is global data, so the ships can be anywhere in the world. And in our use cases, most often people are interested only in specific geographic area. I have a visual example for this later, but because people are interested mostly in specific area, for example, as we are here in Dubai today, perhaps the surrounding area, the Gulf, is mostly interested to the local statisticians or analysts. So this allows for us to use optimization that is geospatial partitioning. And what we do, we use index, geospatial index, H3. Probably you'll hear quite a lot about this index today. And this using the location information, so latitude and longitude of the ship position, and creates a unique index which can have different resolutions. And the benefits of using this index is for us that we can partition our data, and users will have examples on this. Users can request data only for this region. So instead of reading the global data set from our data storage, users will be able to say, I want only this area of the world, and only this area of the world.
Excuse me.
It's called in jargon predictive
Hello.
program. It will be read only. The rest of the data will stay in storage and will never be
Excuse me.
to the memory. Also, finally, we provide support for additional
Hello, am I audible?
libraries, namely Apache Sedona and GeoMesa. Apache
Hello,
Sedona
am I audible?
is a big data geospatial library. So, of course, we have the classical geospatial libraries like GeoPandas
Hello.
and many others, which probably you're familiar with. But when the data gets bigger,
I got host calling.
processing in parallel. Okay, moving on. You've seen simulations.
Yes, we can hear you.
Spend too much time. The data is acquired from the ships by satellites, a constellation of 65 satellites.
I got
guaranteeing that there will be good coverage at every point of the Earth.
The young nigga phone. Where is Ali with the motherfucking door?
Okay, it's not mine. Right, so the data is coming to terrestrial stations, to our data service
I be
provider. And finally,
ballin'.
it's
Like my
stored
nigga
in
Mo.
our data storage, which in our case is the AWS S3 storage, bucket storage, which is object storage. Again, the vessel identifier is MMSI, which is the unique number of the transponder of the ship. Of course, there is additional number which identifies the ships. This is the IMO number. But because sometimes transponders or the transmitting equipment gets replaced, the IMO is more stable number, which stays always with the same ship, and MMSI number sometimes may change when the transponder or transmitting equipment changes. Moving on. I said that earlier that we are using a grid system. So this is the geospatial indexing H3, and it's based on hexagons. Why it's hexagons? It seems there is a lot of theory on this. There are different tiling systems and grid systems, and basically the choice is between a rectangular tile system, which is the one on the right-hand side. Also, this is the tiling system in the red. This is next in the middle, the green example is hexagons, which we are using, and also there are triangles and different tile systems, but there is a lot of documentation that hexagons provide the most optimal tiling system for geospatial indexing system. I wouldn't go into too much detail because of the time reasons, but you can go to, if you're interested in more details, this is coming from Uber, the company that provides mobility services. And on their engineering blocks, they explain in very much detail, very deep detail about the tiling system and H3 indexing system. Okay. So I'll skip a few slides here, but we use different resolution. So the resolution in H3 system, H3 indexing system, it varies from 0 to 15. So altogether we have 16 levels of resolutions, and based on how granular we want our tiling system to be, we select one of these. Of course, the coarsest resolution covers a huge area. So in essence, it splits the world sphere, almost sphere. Of course, it's not perfect sphere, but it splits the the globe into 122 hexagons. And you can imagine each of these hexagons has a big area, covers a lot of surface area. And we use this for our geopositioning. So what I was telling you earlier about the predictive pushdown, allows us to specify which part of the world user wants and extract only this data from the system. Of course, when the users go into much more details, we will be talking about higher resolutions. For example, the highest resolution is covering very small area. So you can see as in the slides, there are a lot of zeros before the 9. So this is down to centimeters perhaps. Okay, so and how these hexagons fit into each other. Again, more detail on the Uber website. But we have these hexagons, so this is, imagine the highest resolution, and then we have one of the more granular resolutions hexagons. And although ideally they should be fitting perfectly, it's not perfect fit, it's impossible. But there is a big overlap between the hexagons in different resolutions. Of course, there is convenience functions provided that allow you to convert between the resolutions, so it's not a problem to calculate from a more granular resolution to a more coarse one. And very quick example, of course, we'll see more code later in the day, but just to give you an idea, it's if you're familiar with Python, it's just you import the library. For example, I give these variables to latitude and longitude some values, and I select that I want resolution 9, and then I use the library which is already available by importing it, and use this function, convert coordinate geo to h3 is the function, is the method, and provide the variables as parameters to the function, and finally the library gives me the output. So this is the typical output for the GeoIndex. And the benefit of using this index, it accelerates the computation, of course. Of course, an alternative way is to use Sedona or other geospatial libraries, for example, for geospatial joint. If you, for example, if you have one table with points and another table with polygons, and you want to do a geospatial joint between the two tables, of course, Sedona have convenient and optimized, speed-optimized functions to do this. But it turns out that by using H3, we can squeeze out much better performance from the system and do the same operations for joining the tables. Quick example here, how a user would approach using our system and the data that is stored there. For example, this is UK, where I live. And if I want to query a certain port area, for example, with this indicated with this polygon in the bottom chart, first I would acquire the data for this polygon. So as you probably, it's a bit small font, but hopefully you can see. I can select that I want to extract data from just geohash, and then next filtering in this line here, which probably I cannot highlight, but where my pointer is. Next filtering is exactly using the Sedona library and supplying the polygon, which has been defined by its points, corner points, and submitting this polygon provides the second level of filtering. Why I'm not using just the polygon to cut out the data that I need? Because of the speed considerations. By submitting this first polygon as a filter, geospatial filter first, I ensure that I benefit from all the optimizations in the system and extract only the data that is relevant to me in this part of the world. All the rest, 121 hexagons data stays in storage, is never read into the memory. So this provides huge boost to speed and also does not require the resources, the RAM memory, to read this data into the memory. So this is one of the optimizations that we have designed into the systems the users can benefit from. Of course, in different use case, when you, let's say, want to track a ship across the world, you are not, you cannot only use this part of the world, only one part of the world or one of these hexagons. You then need to acquire a number of these hexagons to be able to track your ship and do your processing of the data. Finally, since we're here on the code page, just as an introduction to the exercises that you'll see later, we can do some further filtering. For example, to say that I'm interested of ships that have been in this area between these two dates. So this is the standard Spark format of doing this. And here I say that I want to get only the unique numbers of MMSI. So if a ship has been twice or submitted more than one message in this area, they're ignored. And finally, I'm counting how many unique MMSIs have been in my port area. Of course, users can are free to define their own polygons, multiple polygons, any shape they want. And we are planning to provide some ready-made polygons of the world ports at some point in our system, so the users don't have to define their own polygons. This is the use case when they want to track the ships arriving and of multiple ports, global ports. The global trade trading tracking. Moving on. So how we are obtaining the data? Perhaps I haven't sent.
Охуел мне звук выключать, гондон.
We are using API, and we're using it quite frequently.
Что за хуйню ты рассказываешь
live
тут?
stream information coming constantly from the ships, and you can imagine.
Иди нахуй, хуесос.
Having less frequent updates, then
Да,
information wouldn't be that
бля.
That's why we decided that every 2 minutes we are reading data which is provided by our service provider Hexagon, data service provider Hexagon, and reading from the API every 2 minutes and storing the data in our storage.
Что ты там пиздишь? Завали ебало, ты заебал всех уже нахуй.
Of course, alternative systems can be used from other cloud providers. So then the data is further cleaned and compacted into the currently weekly backups. So weekly archives, we're using Parquet archive to compress the data. And very soon we are developing this functionality. Currently, it will be also alternative option for hourly geoposition archives. And users can access both. So users have access to the weekly 4-hourly geoposition archives, or if they need something more recent in terms of data, they can access also the 2-minute update. So 2 minutes after the ship has entered certain area, they already know it. For most use cases, for our users, this is much more than sufficient frequency. How the data looks like in storage, I wouldn't spend too much time on this, as these are technical details, but just to give you a flavor of it. So we have our bucket storage in the cloud provider, and we use weekly archives. So this is, as you can see in this slide, for each week we have a separate folder. And in this folder we have Parquet data archive, which is geoposition. So you can see here, this is the 0 resolution of H3 index, and this is how it works when the user specify which indexes, which geo parts of the world they're interested in. The system uses this information here to extract only the relevant part from storage. So putting it all together, this is probably a quick summary of what I was explaining so far. We have 2 minutes updates from our data service provider. Each update is 10 megabytes. Currently, we have around 40 terabytes of data in our buckets. And we are using serverless technology for this, namely AWS Lambda functions. Why this? Because providers meta availability, and we don't have to cater for our server architecture. We don't have to have a server. We don't have to update server. It's everything managed for us by the cloud provider. And we are just firing a new Lambda function every 2 minutes, which reads the data and saves it into the right place. As I said, we're using cloud storage format. Then after the data is stored, Spark, Apache Spark, what I was explaining earlier for distributed processing, is used to compact the data, and the users also using Spark to process their queries, their jobs in parallel, which accelerates their jobs hundreds of times. Finally, behind the scenes, we're using Kubernetes, which is the orchestration network, container orchestration framework, open source again, and highly recommended for the use. This allows us to scale up and down the Apache cluster when the demand comes up and down. Any questions? Anything online?
I think you covered it. So thank you, Alex. So, I mean, we do have some questions from the chat, but I think that you have answered them, especially they are very much interested in the tools and how the system can scale up and scale down, but you already explained it in your last slide. So if I can summarize, right? So we have spent 2 years to optimize the system so that you don't need to do it again. What you need to do, just to use them, right? And of course, there's always a challenge about the knowledge, but this is why we are here, right? All of us is here. Go ahead, you have questions.
Thank you for this really interesting presentation, very practical and straight to the point. My question is related because we are using here the cloud system. So is it available for us as Official Statistics Institute, or we need to have a special account? Because you know it's not a free account to use Amazon cloud. It's usually.
You don't need separate account with Amazon. Everything is done through us. You just express your interest. You receive your authorization, your codes, everything that you need to. And you don't actually deal directly with Amazon. Amazon and the cloud provider is behind the scenes.
So everything is in the cloud, so we can use it directly.
You can use it directly. What you see, I have it here. Perhaps I'm still sharing my screen. Perhaps, yes, what you see is this dashboard, which after it's the IP key, so you'll be given an IP key. So for example, you have, after we create account for you with us, you can create your IP keys, and there are examples later that explain how this are used in more detail, in technical detail, but in essence, you can use these keys to access the system. So all you need to send email to us, especially for statistical institutions. A day later, you get authorization, and you can start use the system directly through this dashboard. And from here, you can monitor your jobs. You can see how much resources are using, but you don't have to deal directly with Amazon. Of course, in some more specific cases, if you have a big data set that you want to join with AWS, for example, anything custom data or anything that you might have. In this case, you might want to submit this to the Amazon separate bucket or give it to us, and we'll make it available for you to link with your data in AWS. So in short answer is you don't have to worry about cloud providers. We give you access to this dashboard, and you can monitor your applications. For example, you can see current users are running jobs, and it tells you how long you've been running for, what resources you're using, how much time you have used. You can track your jobs, you can optimize them, and perhaps later I'll show a bit more detail about optimizing your jobs. But no, you don't have to worry about
this is my question, is that you can benefit from the Amazon and the services existing in the cloud for this kind of statistics.
It's behind this, so there is Amazon services, everything is running in the background, but your interface with our system is this portal. You don't have to worry about Amazon. Unless you're doing something very sophisticated that you might want to develop your code in Amazon and benefit from this data, but then we have to discuss it separately. The typical user is interfacing with the system through the portal and jobs that will be demonstrated a bit later. You get a very good idea.
Thank you.
Thank you. Anyone else? Yes.
Hi, good morning. This is Hassan Al-Kathiri from Zayed University. I have like maybe 2 or 3 questions. The first one, for example, how we can, how much reliable and valid the data that we will collect it from this database. So for example, are those reliable if we would like to make some analysis on them and for example, submit it to the, according to the SGD's indicator. So they will approve that, okay, this is what are, for example, for the CO2 emissions, how much pollution is there on the marine. And my second question is related to if we would like to reduce the time that we will make analysis on the data, because there is a large number of data. So is there like a specific library that we can go to it to reduce the time that we need to execute whatever we would like to test it? And my last question is related to blockchain. So is there any project have been contacted on this data related to blockchain? They use it, for example, to make an agreement between the port and directly to the ships itself. Thank you.
Okay, you start.
All right, thank you for the very insightful questions. I guess I could start on the first question relates to validation on the data absorbed and if we can rely on that data. I will further explain with more detail how that data came in, but it works pretty much on a base-to-base, in case-by-case basis, meaning that the best validation you could have is posting out your method so everybody could replicate whatever you had and could identify if that's proper. A proper way, perhaps, if you're an academic, as I noticed, is of course publishing your methods as part of your research. And that always works pretty good as a bulletproof test for the validity of the results afterwards. And then of course, you can use those results if your method is strong enough for policy making. So that could, from my own experience, that could be the pattern to go. You asked something about reducing the analysis time?
Okay, so reducing analysis time and libraries. Starting, if you don't have much experience with distributed programming on Spark, you have to have a learning curve. And we provide some examples that users normally follow to achieve best results. So it's quite easy when you're especially a novice user to write a query that takes a lot of resources and wastes them and just produces nothing in the end. But we have quite a lot of examples, even in our training videos, everything that explain how to best optimize the system. And also we have examples later. In our dashboard, we are providing estimation of your job efficiency. So you can see, probably I can quickly show, I'll show it later. Yes, you can see a chart of your resources used, and there is a single number that tells you that your job is or your job is 10%. And because for novice user, it's quite difficult to write optimal chart. And they can start with something, they see, oh, my job is 5% efficient. And they can change something and see, oh, my job just got 50% efficient. So it's easy to learn how to follow the best example and best practice in this case. Also, libraries, we supply quite a lot of libraries that we think are useful for you, but we have the flexibility because we're building our Docker images with additional libraries for specific user needs. If you have some very specific needs to compute some functions, statistical functions or anything like this, we can include the libraries that you want in the image, especially for you, and you can have your own, let's say, customized cluster. When you start your cluster, your job, your image that is created specifically for you will be extracted from storage, and you can have all the libraries that you want. At the same time, the rest of the users don't have to worry about that much about your libraries, because it makes their image quite big, and they can benefit only from the optimizations and the libraries that they're specific to them. So this is, if you want, mass customization of the system to the needs of the users, so these groups of the users. So yes, to sum it up, we have a good support, good examples how to get quickly to proficient programming skills with Spark, Apache Spark. A lot of people have followed them, and I would say they have achieved very good level of sophistication in their jobs. And yeah, everyone starts somewhere, tries, makes errors, but eventually learns and achieves good results in terms of job efficiency. There was something on blockchain. Okay, I can cover this. The system, actually, we're using it for AIS and geospatial data, but it's a generic system. So it can be used for anything. So if you think of a library, or even if you write your own code, we can include this into a system as long as it's suitable for distributed programming. This can be executed and can run with blockchain or anything that comes after blockchain. So it's a quite flexible system, and depending on what you want to use or what code you write, we can include it into the system, and it can run ships with blockchain or anything else. Even different data sets can be incorporated. Also, we haven't done this yet, but perhaps is in the future roadmap. We could include deep learning libraries, of course, for people who were yesterday in the machine learning course. We can include deep learning libraries in the system, so we can use any machine learning best practice or algorithms, methods that you can think of, and combine them with the data that is available through the system. So again, our clusters are not GPU enabled yet, but in the future we can do this. So the answer is, to sum it up again, blockchain, we haven't tried our system with blockchain, but I'm sure that it can take almost anything. Yeah. Yes.
Thank you for the presentation. Just wanted to ask, I'm Islam Zaki from Higher Colleges of Technology, also an academic here. If, for example, if there's an emergency and on any of the ships, and there's like no data coming out of the ship anymore because of the system malfunction or stuff like that, how can you still triangulate and track them using the hexagonal system, global hexagonal system?
Yes, okay, I'll cover this question. There actually happens quite often that some of the ships go dark. This is the technical term that is quite used. Yeah. They switch off their transponders, maybe sometimes intentionally, maybe sometimes malfunctioning of the equipment, who knows. But using the last location of the ship, we can probabilistically approximate, of course, when the time passes, the ship may move, but they don't move that quickly as airplanes, for example. So there are some plans that we could actually use last positions of the ships to estimate where the ship might be in the next 10, 20, 30 minutes. So yes, this is one way. Again, we have discussed, and we are perhaps in the future, we'll do something about when ships start reporting wrong positions. So even in some extreme cases, ships start sending wrong signals. So instead of the ship being in one location, it reports position in 100 kilometers, miles away. Mm. So again, with machine learning, we can check the consistency of the message stream and find out whether the ship is reporting a reliable position.
And this is done real time, yes?
This is real time. Okay, with 2 minutes delay.
Oh, yes.
Near real time.
Okay. Thank you.
Thank you. I don't see any questions from virtual participants. Everything has been answered. I think that there is no other question from your from in-person participants. Do you want to say something?
One last thing, actually, because we mentioned real time. If you look at the screen here, this is the imputation side. So this is where we read our satellite data through the Lambda services. And this actually, for example, if we look at this diagram here in our dashboard, which reports the live information in real time. If I take, okay, this is the last day, for example, it tells us how many ships currently the system tracks. So you can see every minute we had some blip here, perhaps, for example, where the ships dropped to 9,000, but immediately next minute, I would say next 2 minutes, it compensated for this. So even if we missed some ships here, next 2 minutes we get their position, reacquired their position. So it's quite yeah, real-time system. Everything monitored.
So there's a lot of work has been done on the background, so that you don't need to worry about this. So I will just one more point. So you asked about this accuracy on the calculations. So the work of the AIS Task Team is not only dealing with the data and the infrastructure, but we also working on the methodology, a common methodology. So once we develop a methodology, right, we distribute to countries for consultations, and we indicate that, okay, we recommend this kind of calculation algorithms to calculate the maritime emissions, right? And then, of course, there will be a certain harmonization on the methodology of calculations, because there are many ways to calculate certain things. So we are working on this also. So I would propose, before we go for the next presentations by Gabriel on the content of AIS itself. So we have heard about the infrastructure behind it, right? So next presentations will be a content. What is AIS? What are the variables? What are the limitations and so on? And followed by a demo by Cheryl later on. So I would propose that a break for 15 minutes. So we'll go back around 10:48. Thank you. Okay. Yeah, we started. So we do have the new presentations from Gabriel. So Gabriel will make presentation on the data variables and certain consideration on how you use the AIS. So Gabriel, maybe you can start your presentation.
Hello. Okay. Good morning, everyone. Good afternoon to those that are following us through the virtual environment, to a Zoom meeting. There's some early birds as well. If you don't mind, I will just stand up here. I rather prefer to be standing. I promise to keep as much distance as we require as per COVID restrictions. So, yeah, we're coming in. We can just wait a couple of seconds to people to settle down locally. Yeah, I'm sorry with the cameraman, so you will have to be following me around. You had it a bit easier this morning, so. Right? People is accommodating now, yes? Right, so meanwhile, while we were at break, we check out some of our visitors from the virtual meeting. We got people from the Philippines, from Indonesia. We got some from the UK, from Ireland, from Latin America, some people 2 a.m. in the morning connected to this session. And that reveals pretty much the interest behind using this type of information for generated timely statistics. And importantly, that it is available for everyone, in the sense that if you have some programming, if you know some Python, you can scale it up, and then as a learning curve, you can get on more complicated stuff. However, we're also welcoming people that are starting with some, that want to improve their programming skills, to start from a very basic level and go on from there, right? We try this to be as democratic as possible. So my name is Gabriel Fuentes. I am a PhD researcher at the Norwegian School of Economics. That's in Bergen, Norway. I should be on my last semester of the PhD, already being assigned to be a professor for shipping economics and analytics starting next fall. So you might relate that my profile is on academia. However, I also been engaged with the operational aspects as I'm a licensed ship officer, meaning that when I was working in industry, I used to sail ships, bigger ships. And most of the time I got the opportunity to visit the UAE, unfortunately not Dubai ever, or Jebel Ali, that was quite close, but Fujairah, that is a very traditional rendezvous point for tanker vessels aiming to load oil, crude oil at the Gulf. So with that said, I'm now engaged on shipping economics and analytics. I got a certificate. I am a certified ship broker as well from the Institute of Chartered Ship Brokers. So that makes that I could get some different hats, and that gives you some information on the types of questions you can ask me. Pretty much I have a very broad spectrum of expertise in things that you might relate of, including programming and working with big data environments. I was invited by the UN Global Platform, the big data group, to come up here, pretty much relevant and related with the work that we're doing for calculating emissions and deriving statistics from AIS. So before we get to that section in the afternoon, I would like to make an introduction of what the data is. And that helps in building some background that could help us working or have a smooth transition in the afternoon with the practical exercises. So we're going to talk about the United Nations Global Platform, AIS infrastructure. And we'll be talking about data variables. What are the variables? How are they constructed? And what type of variables they are. So we're going to cover today, as part of the agenda, a brief introduction on the concept of AIS working as a tool for deriving statistics on maritime indicators. Then we're going to present some part of the architecture, perhaps a bit of overlap with what Marky and Alex have presented, but not too much. And then we're going to explain truly what the AIS is, where does it come from, how is it generated, and what's the whole function of it. We're going to close with some vessel specifications, telling you about the technicalities of vessels and how that works in favor of merging it with AIS data and having timely statistics. We're going to close out with some case studies, with some of the projects we've been developing with AIS data. And we're going to close with some questions and answers at the end of the session. However, I do encourage you that if there's any pressing question, you just interrupt me without any problem, and we can answer those accordingly. Also, we have some things on the chat. I think Marky could help us following that as well. Thank you. So the first concept we'd like to explore is the strength of individual vessel behavior. What does that mean? That if you kind of follow one vessel at a time, you could have very valuable information. However, you cannot scale that up or try to think that to be a sample of what's going on within the area that you're exploring. This specific case over here is for vessels transiting the Suez Canal. That's an algorithm we derive within our research projects, where we can identify when does a vessel start anchoring. Anchoring is like when you lay down your anchor and wait for your positioning within the canal. And that tells you information about the waiting time of the vessels before transiting the canal. Then you got information on the vessel transiting the canal itself. And that information is collected and aggregated with other vessels information. Why do I stress on the importance of vessel behavior? Pretty much because distributed computing is about, and let's try to think about it, divide and conquer. You have this massive data set that you cannot process on regular computers. So what you pretty much do is like create a blueprint of how you're going to process this data. And at least within shipping, by bringing it down or cutting it down to processing information for every single vessel is a good match for big data environments. And here comes an example of it. However, if you just aggregate information, you get distributions like this. The information on the left is about the Suez waiting time. So pretty much collecting all the vessels in a period of time, checking out what they were doing. That is quite evident if you look at the graph, but telling the code to do pretty much the same things that you just did. I know you did it because it's intuitive, Like you check out when the vessel was turning and you kind of identify the waiting times. And then you check out when the vessel was crossing and you identify the transiting times. Well, we tell the code to do that and pretty much collect everything, aggregate, and give us these very nice distributions that, as we have compared with Suez Canal authorities officials, are very close to what they show in reality. The advantage of this, almost in real time, you can get that information. And you may remember the accident at the canal by the Ever Given a couple of months ago. That disruption was, or could have been, identified in a glance by monitoring that information in real time. And perhaps some vessels had, or some companies had, because you see after the accident, some vessels already deviating around the Cape Horn to avoid this disrupted path. The graph at the right talks about the Suez transit times. If you realize a very tight distributions with very small variance around the mean tells you like how much time does a vessel needs to cross the Suez Canal. And that's important because if you're a ship owner or an operator, you might be interested in knowing in advance approximately how much you're going to wait, because then you can control your fuel consumption vis-a-vis your vessel emissions. This is becoming more and more important within the maritime industry, because vessel emissions is not just, controlling vessel emission is not just like an hypothetical goal, but it's becoming international regulation pressing on that, and also commercial pressure after that. There's some discussions now on the table on companies being charged or having carbon taxes relevant to this. And of course, having the proper operational management gives you some leverage for reducing your emissions and having commercially feasible operations of your vessels. If you like to follow up information, I do encourage you to check out the presentation. There's the link there. And we already have a paper published on how to derive information from the Suez Canal transits from AIS directly. So I invite you to go and read out the paper and follow step by step how to do it. Another interesting example, and this is very actual, we're working together with the UNGP and the Maritime Technical Cooperation Center in Latin America and TCC in order to generate real-time emissions calculations for a regional area, that area being the Panama territorial waters, Panama being importantly and known for having the Panama Canal, which passes approximately 6% of volume by cargo of the worldwide cargo. So that says that this choke point has a very strong potential on reducing emissions on a global level. So that's why we're very interested in generating this information in real time or close to real time. And why is that? Is it important? Because then you can have very swift policy shifts after you got information on high levels of emissions and such. There's also a link so you could visit out information on the project. The project that you will find there is just a prototype so far. Our idea is that we will make this live in a couple of, in very shortly. We're almost there. So let's talk a bit about the data mechanics architecture. This overlaps a bit on Alex's presentation, but the whole concept in here is that we need to follow up that you as a data scientist, you're gonna be more related to this section. As Alex mentioned, there's a lot of things happening behind curtains, and those you could relate to the blue box at the right. There's an AWS cluster working with your big data. You also saw that we have an S3 buckets where the information is stored. And our dear friend Alex is working very hardly on streaming that information and have it available in good time for further processing. So pretty much Alex doing whatever is not on the red square, right? Together with data mechanics and the Kubernetes platform that they have built very swiftly. So talking about the data source, so if we expand this architecture, we have some database behind. You could think of those as the S3 buckets. The S3 buckets from the AWS, the data, the database on the cloud. They are sourced by commercial operators in the sense of the AIS. one of them being ExactEarth, globally known commercial supplier of AIS information. And then you got Fleetmont. And the main difference is that there's some information that one of the suppliers doesn't have that the other suppliers can provide. So this makes it important in terms of availability. Together with, we had information with IHS market, and that relates to the vessel specifications. What are the vessel specifications? Pretty much the vessel's name, the vessel's unique number, IMO number, the vessel's length, width, draft, and we're going to explain a bit more on the details of those later on. So what is automatic identification system? We've been talking about almost 2 hours about it, and perhaps there might be some legs around the concept. So first of all, this system was made mandatory by the International Maritime Organization in 2002. Hence, it was applicable, as Marky said, a couple of years later. And it was mainly required for collision avoidance, so mainly for safety reasons. So we were not meant to have this information for research or for generating statistics, but that becomes an important collateral because the information is so good that you can derive what a vessel is doing. So that's pretty important to take in mind, to take into consideration when you're working with this. And it's applicable to any vessel of 300 gross tonnage and upwards, gross tonnage being a volumetric measure of the vessel, hence the size of the vessel. And for vessels engaged in international waters. What does that mean? That anything that is bigger or close to the size of a tugboat and sails on international waters is mandatorily required to have an AIS, right? You are not allowed to switch it off unless for very pressing reason that makes the information very available. So you could not have the discretion to do it because, right? And of course, cargo ships of 500 gross tonnage, if they're just sailing locally, they're also required to have that information. So once the main use, collision avoidance, and you can think of several collateral uses. Security surveillance. There was a question early this morning about if you could use this to identify vessels being harmed or vessels disappearing. In that sense, it has been used by some countries to make security surveillance and make safety surveillance that all the vessels are okay. You can have emissions calculations upon that, vessel emissions estimations, global trade flows, trade patterns. You can identify fisheries and illegal activities on fisheries. Check out underwater noise as well. There's some research and literature related to how to identify the pressing matters of shipping on underwater biodiversity. Importantly, as we learned from our voyage to Dubai, the importance given to marine biodiversity here. So this might be of interest to some biologists in here. And then of course, optimal routing, how to make the best vessel route so you can emit the less. So the information on data, pretty much the AIS data is coming up at least from the global platform, we have it at most every 2 minutes with a frequency of 2 minutes. So we have something about 310 million records per year, and that's increasing. We had some research where we have identified, like from 2015 compared to 2019, there was an increase of almost 80% on the size of the raw data. So that tells you something about this information and that how relevant it's becoming and valid to generate new statistics. Of course, you need a big data cluster to handle this. You cannot just put this information in your laptop and try to run it because it's either you will not be able to allocate everything in there due to RAM memory restrictions, or you will not have enough time to process everything, and the data keeps coming while you process. So that's to take on consideration. So far, this has been sourced. I think Alex mentioned a bigger number, but at least what I read from the lower from the AIS platform is that they have 65 plus low Earth orbit satellites, and that makes it relevant because AIS works with radio frequency. Some of our speakers earlier explained that if you go to Jebel Ali and you just put a radio very high frequency receiver, you will be able to collect that information as well. This is straight information that comes from vessels. And they have lower Earth orbit satellites because then they can collect that as radio frequency information at the same time. So Marky did explain something around this and pretty much how AIS work. I think I will just surpass this. We got this cover. And this is the important part I like to cover. AIS variables is standards. So the data that we receive from ships, standardized by International Maritime Organization, and is highlighted on this slide over here. We have two types of data. One that is dynamic. You can relate that it changes often. And one that is static and voyage related information that pretty much changes on a, it's very regular to have it changing within our data points. So within the dynamic databases, variables, this is transmitted every 2 to 10 seconds. However, we receive the information after the collector receives all of these 2 to 10 seconds. They send it to us as fast as 2 minutes, right? From there, we got information source at the ship, such as the ship positions. That means the GPS position of the vessel in longitude and latitude. The speed over ground, that means that how fast the vessel has sailed within the timestamp. We got course over ground, how the vessel has moved related to their heading, where they were aiming. The heading, of course, is where the bow is pointing. And this is important to be stressed because the heading and course over grounds are different, meaning that you could have a vessel aiming to a point, but your vessel could be moving sideways. So your course over ground is this sideways movement, and your heading is where your bow is pointing to, the front part of the vessel. Rate of turn, how fast the vessel change heading when they're turning. And of course, the AIS navigational status that goes from them reporting when the vessel has start anchoring or start sailing and such. And if you realize they have an asterisk, that asterisk means that that information is manually input by the users on the vessel, the officers that are sailing the vessels. Hence, that types of data or variables needs to be taken with care, needs to be addressed and verified before using it straight. Related to the static and voyage information, we got the IMO number and the MMSI number. MMSI stands for Maritime Mobile Service Identificator. And they are both unique numbers to vessels. However, the MMSI number is related with the radio station of the vessel. The IMO number is the unique number assigned by the IMO, the International Maritime Organization, to that specific vessel. So that means that when you are lacking information from one or the other, you can easily turn to one or the other to identify a single vessel. Try to keep that in mind because that information is important later on when we're working on our practical exercises. You might find that there are some vessels that don't have an IMO register, and it could be a matter of a faulty reading or just a faulty equipment on board. You have call sign, you got ship name, you got the type of the vessel. However, this is pretty much generic. You cannot relate pretty much what type of vessel is specifically. You can relate that this is a cargo vessel, but then you don't know if it is a container or a bulk carrier or a tanker vessel. Then you have dimensions, the length, the beam, that is the width, and the draft, that is the underwater surface of the vessel. The draft is important for calculating the cargo quantities for those vessels that are measured with weight. For example, bulk carriers or tankers. When you check out the draft changes, you can relate whether the vessel is loaded, is laden, or in ballast, right? So it's have cargo or doesn't have cargo on it. So this is an important variable if you try to measure exports and imports from countries. However, once again, check it out. You got an asterisk there. You need to take that with care. The destination is also introduced. It's not very reliable because there's no standard for introducing destination, and that could be typos on the destination. So if you try to process this from a data set, then it will be problematic. So destination will be not a good variable to follow. And of course, ETA, estimated time of arrival of the vessel reporting it. So I want to throw a question out to the audience. Check out all the variables. Do you think there's a variable missing out there, something very important for us to locate what the vessel is doing? There's no wrong answer in here. Or there could be wrong answers, but that's okay. We are learning all together. Yes, madam. Yes. You are missing one data set, one variable there. This is very important. What do you think? The IMO number? Yeah, it could be, but it's already there. So it's a variable that is not on the slide. What do you think? How can we identify a vessel? Yes, sir. Yes. 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 Yeah, wonderful question, sir. And I'm going to repeat the question for our friends in the virtual. The professor was asking about, 1 second, Marky, was asking about the emissions given by vessels. It seems that they contributed a lot to carbon emissions, right? Yeah. Well, fortunately, I will give some spoilers. At the afternoon, we're going to treat from 0 to 100 how to calculate those emissions, right? Very well documented methodologies that we have summarized in a way that everybody could follow. And another spoiler, we got information from that if shipping was supposed to be a country, it will be the 6th ranked in the world as an emitter. Around 3% of global emissions come from shipping. However, shipping was not included, and our friend from aviation might know that also aviation was not included in the Paris Agreement. So that makes it a bit strange. And actually, IMO is pushing very hard to get together with the Paris Agreement standards in the sense that how to calculate these emissions on a regular basis. So we're going to touch upon that in the afternoon. We have an introduction on emissions in the afternoon before we get on the hands-on session on working with the data, right? Sir? Yes? Okay, good question, good answers. Yes, we're missing those. However, they do not come from AIS itself. We have to derive those later on. And just before the question, sir, you got the answer or is a question? Okay, just before that, I will just give the answer. Timestamp of records. If we don't have timestamp, all the records will be the same, right? In order for us to derive those statistics, we need to know when those statistics came, at what time do they came from, because then we can sort it out and start following these small dots we saw on the previous slides in order. Otherwise, it will be 1 dot here and then 1 dot in, perhaps 1 dot here in Jebel Ali and then the next one in West Africa, because they were not sorted out and we didn't know the timestamp. Importantly, this doesn't come from AIS, and that's why I didn't include it on the slide. It comes from the receivers. So they identify when the data was received and they stamped the timestamp over there. So now we got that added to the information we had from the AIS information. Sir, we had a question.
You mentioned about fisheries.
Fisheries, yes.
How we can follow because it's important for biodiversity and to know the species in a certain region in the sea. How we can catch this variable? It's not from AIS, sure, but how we can get it?
Well, some vessels have something called AISB because they're under the requirement of IMO, but still they have this in order for have some type of safety relay if the vessel got broken and they need help so they can get identified. But those are the good fishers, I guess. If you're trying to hide your activities, of course, you're not going to have this. And out there in the literature, there are already methods based on deep learning to identify satellite real-time images, merge it with AIS, and have those blind spots of what the vessel is doing. So not just fisheries, but also oil spills, for instance, will be an option. Yes, this is all in literature. I can share with you the papers where they have like specific methods for fisheries later on.
Thank
Yes. You. Yes. All right, so let's talk about the strengths and weaknesses. First of all, if you got to think about this, we got strengths related to, you can generate timely statistics. What is timely? Pretty much at the time that you need it for making decisions. You don't wait for a statistic, official statistics to come out after being processed for 1 week, 2 weeks, when your decision is to be made. No, you can rely on this and take out your decisions in the making. The aggregated data, the strength of having this single vessel generating information is powerful because it makes the data flexible. In that sense, you can aggregate and filter as will. You can aggregate by time period, you can aggregate by vessel type, by vessel size, by events, etc. The strength of the high frequency of the data, of course, it comes on a very high frequency. And then let's talk about the weaknesses. It is not consistent in some areas. It has been identified around the globe that there are some shadow areas where satellites don't collect pretty well what's going on. However, this satellite area happens to be sometimes very narrow, not significant for the whole purpose of deriving information. And most of the time you can interpolate on the information you do have. Vessels can switch off the device. We talked about that earlier. One of those cases is on piracy, particularly on Bab el-Mandeb, well, not Bab el-Mandeb, but on the Strait, heading to the Red Sea. You might have a lot of vessels missing, and pretty much one of the arguments is having their AIS off for security reasons, not being detected by pirates when they're passing. Pirates are getting at the same speed as shipping companies. They're getting as good as them in technology, so they're pretty much dealing with AIS information as well. So they had to take care about that as well, so that's why they switched it off. And there's some manually input data. Do you remember those data sets or those data variables that had an asterisk? Those need to be taken with care. And that is based on crew productivity in timely updating. And I got a personal experience. When I used to sail, sometimes I kind of forget to update this on a timely manner, and I remember 3 or 4 hours later that the vessel was not anchored, and probably we were already at the Indian Ocean or something. So try to think about this. Human errors can happen with this manually input. Human errors does not happen with the dynamic data and the vessels that are not manually inputted. So take into consideration that. A new problem that we just faced up a couple of months ago. China passed a regulation that the commercial suppliers still are wondering how to deal with, and is related with the privacy of information for security reasons of the China sovereignty. So we got a time period where AIS information went off. You had no vessels in China. That's really hard to think. And they've been sorting it out, the commercial operators, and we have, with some levels of success, fill those gaps left by this regulation introduced in China. Into the vessel specifications, you remember we have AIS data, and then to have a full overview, we need to merge it with some other databases. The link between those two databases is either the IMO number or the MMSI number, the radio number. So the cargo information, and that was one of the questions, is not available in here. You don't get cargo information. It's not visible. You don't know how much cargo the vessel has loaded because it's not required under regulation. So a good way to follow, and I make the quotes in here, is by observing vessel segments based on vessel characteristics and then relating to how the vessel has changed their draft. Remember, draft an important variable of the underwater surface of a vessel below the water surface, right? So that's like the exposed area of the vessel into the water. And that tells you if the vessel is deeper, that means that the vessel is loaded. If the vessel is shallower, that means that the vessel is not loaded, or in between as well. So you get the opportunity to derive that. AIS information, raw AIS is very difficult to segregate alone. So you need to append it with vessel specifications to get the filtering that you're required to have. Importantly, our supplier, IHS Markit, is the sole IMO responsible for providing these unique IMO numbers. So you can rely on them as being a reliable source of vessel specification data. They have to generate this IMO number to vessels to get to see, right? So we have approximately, Marky mentioned something about 100K, but if you include scrap vessels, that means vessels that's been cut down and are no longer in existence, you have something about 200K plus. You can identify their ownership track when vessels change of owners. And this data is pretty much manageable within your local laptop, meaning that it fits into your RAM memory. However, we have that on the global platform, and we're going to touch on that on our afternoon workshops, and you will have a closer touch to that. This information is not updated as fast as the AIS data, so that's to take into consideration. However, it's not needed because you don't have vessels coming out of a shipyard every 2 minutes, right? A vessel construction takes approximately 2 years, so you could be safe that this information is reliable, even though it's not updated as frequent. More than 50 variables in there, including things that we saw before, highlighting IMO number and MMSI once again, hence our connector to our other database. You got draft, you got length and beam, the name of the vessel, TEUs of the vessel, capacity, how much containers a vessel could load, the flag, the deadweight tonnage, that's the weight of the vessel. Then you got gross tonnage, engine power, as Marky mentioned before, is really important for calculating emissions. We got that information from there, and the fuel type, of course, and many, many, many more variables. You will be able to observe all the variables on the afternoon as well. So let's start with the case study. And you remember I mentioned the role of a single vessel, the power of a single vessel information. That is connected pretty much to the divide and conquer strategy. Get one vessel at a time, and you will get all the information of the vessel when you aggregate that down. Plus the advantage of having this segregated information that you can filter later on smaller scales. We got an example here of a paper we published a couple of months ago in a way to calculate bunkering statistic. Bunkering is vessels stopping for fuel. Vessel getting to the vessel's gas station, I was like to call it, to get fuel and to continue their voyage. So for a vessel to get fuel, it needs another small vessel to come alongside. That means by the side, and connect a host and get that information. So you will be pretty much having that knowledge. We transfer it to the code and let the code tell us when the vessels start waiting for that bunker barge to come alongside and start pumping the fuel. How long does that fueling process take? And then with that information, we could scale it up and recognize from every single port in the Mediterranean, which of them has the better service. This is relevant because if you're a shipping operator, you will try to go first where the fuel price is cheaper, perhaps, but then you might overcome that with a cheap fuel port, but a very expensive in the sense that you will have to wait a long time. So you rather prefer to have a middle ground where you have like a relatively middle price, but in an efficient port. So in that sense, you don't have to speed up your vessel in order to reach at the same arrival time that you're expected to arrive, right? So try to think on that concept. It's not just about price. It's about time being priced and emissions at the same time being reduced, because if you speed up, then your vessel is certainly going to emit significantly more than a vessel that just go on a regular, let's say, safe and steady speed, right? So within the closing remarks of this presentation, try to think on this. Is it truly necessary to query through all vessels at all times? I don't think so. Probably your research, or at least the things that you're interested as a governmental office or as a private individual or private company, is segregated on a very small area. So that means that, as Alex introduced, you can just filter out the information that you need from that small area, and that makes your data significantly more handleable. So pretty much divide and conquer. Be aware of the manually input variables. Always think about it when you're working with this. And AIS data is not foolproof, meaning that it doesn't mean that because you had a very reliable commercial supplier, your results are gonna be good as well. So try to think about this. There's like this lane of information in between. Always be suspicious about the data. And it comes, I think, to the question of our colleague, our academic colleague, that can you rely on the methods of this? Well, you can as soon as you have the information of the methodology the other persons use, completely transparent and posted in a way that it could be replicated. The strategy that I like to use is my personal strategy. It's like I have my prototype codes ready for one vessel at a time on a very small sample. So I get that control And then I escalated that to the big data environment through the UN Global Platform. So I got some very small samples of AIS. I do all my transformations up there. And when everything is ready and I know it's foolproof, then I transfer it to the UN Global Platform and expand it to the big data environment. Present results in form of distributions. Remember, these distributions that came out there. This is important because that gives the viewer or the reader of the information or the policymaker a sense that you are very transparent with what you're showing, because they will be suspicious if you're transferring to them absolute values, saying like, okay, vessels are going to wait 10 hours. Okay, it could wait 10 hours, they could wait 9 hours and a half, they could wait 10 hours and a half. So be transparent about publishing your results, and distribution is a good way to do that, right? So with that, I would like to give floor to any additional questions. I do believe there might be some on the chat. I saw the chat popping up. I will just read them. Yeah.
Yes, I think there is no new questions
Okay.
for you in the chat.
Yeah.
But maybe someone from the
audience.
floor.
Yes, sir. One here. Yes. We got the microphone.
Yeah, we have microphone.
That way we help out the people in the big virtual environment. Yeah. Yes. All right.
So the vessel specifications is entered manually by the member crew, right?
The AIS vessel specification, we have some defaults. Fortunately for us, that's the default and is introduced by the AIS maintenance company. So that's not introduced by the vessel crew. The draft, that is that information of the vessel changing underwater surface, that is introduced by the crew. By AIS Market, that is our other vessel specification supplier, all of that information is not, well, it's introduced by that company, but you can rely on that because they register the vessels. They have registered every single vessel. Pretty much because they got the contract with the main organization that handles vessels. So you can rely on that. Yes.
Thank you.
No problem. My pleasure.
So you mentioned at the beginning that if we manage to gather the data and analyze the data, we will be able to avoid the Suez ship that was stuck there. So how do you think that this is possible?
Oh yes, wonderful question. Wonderful question. That comes also a very interesting research question from our academic colleagues, and is the fact that how can you make decision-making processes fed by big data? So it comes into the literature concept of data-driven decision-making. That is pretty much getting these distributions, these statistics, embedding them in mathematical programming models that accounts for these uncertainties and allows you to plan in due hand. So that's pretty much something that we're working on as well, trying to use this information to feed out decision support system models for operational decisions. Yes, good question. All right. Very good. Well, I do appreciate very much for your attention. I do invite you, if you have any further question, you can visit my website. I there have all my applications from AIS, including codes, pseudocodes, and ways to replicate data. Also, my papers are there. Feel free to contact me either by LinkedIn, GitHub, Twitter, or by email as well. So, gabrielfuentes.org. Thank you very much for your kind attention. I can address any other further question by one by one. Yes.
Thank you, Gabriel. I mean, of course, the operational knowledge as a seafarer, which is very important, to have an understanding that, it is challenging to update the AIS transponder, right? Especially for those that the static informations. So the next, so we will have some kind of like a demo on how we can use the UN Global Platform. So this will be like a step-by-step, demo on to calculate certain indicators. So we have our colleagues from Asian Development Bank, Cheryl. So whenever you are ready, go ahead. You can share your screen. Unmute Cheryl. Thank you.
Great. Okay, so good morning, everyone, and good afternoon and good evening to the other participants. I'm Cheryl Chico. I work for ADB and I'm a consultant. And currently, I'm working on an AIS project on Pacific Islands, and I'm trying to estimate the trade volume. And I'm using AIS data for it, and I'm using all the services available in the UNGP, in the UN Global Platform. So my goal for you right now is to give you a view of the services available on the platform. Currently, we have around 2. So we have what we call code services and also analytics services. So conveniently, all the services available by UNGP is located in one website. So all you have to do is to access this website of that officialstatistics.org to be able to access the global platform. And then within that, you'll have access to a code service and also to analytics services. So for the code service, if you are a data scientist or if you're a developer, you'll be, for sure you're familiar with Git. So for Git, we're using GitLab, and we're using it mainly for source code management. And there are also other functionalities available on GitLab. So that it's a DevOps platform, so you can definitely do CI/CD integration here. And it's also a way for project management. So if you're used to the agile project management, it's also a good collaboration tool. Later, I'll show you how all of this works. So that's the first one, code service. It's also available in its own website, code.officialstatistics.org. So other than the code service, we have the analytics services. And the analytics services is made possible through Jupyter Hub. And it's also available on its own website, notebooks.officialstatistics.org. So what Jupyter Hub does is that it has a bunch of different notebooks or different computing environments that is, it really depends on whatever you need. So the first one, analytic workspace. This is, I think, the most basic data science environment. So it contains all the basic data science packages that you need. And then if we need more computing power, so for example, we're going to work on AIS data, we have the Task Hub Analytic Workspace. So this is our main entry point to the AIS data. So again, these are analytic workspaces available in Jupyter Hub. And the good thing about this is that you don't have to install anything on your computer. You can just access the website, and then it will give you access to all of these computing workspaces. And then finally, it has been mentioned by Alex earlier. So remember that since we're working on big data, the way for us to process big data, AIS data, we chose Apache Spark, and then we're managing containerized Spark application through Kubernetes. But fortunately, we don't have to think about all of the infrastructure behind, because the UN Global Platform has partnered with Data Mechanics so that they'll do the managing of the Spark applications for us. So it means we don't have to worry about determining how much executors we need for our Spark applications or how much RAM we need for our Spark applications. So I think this is the best part of it, because it really makes working with Spark, even though you don't have any prior knowledge on working with Spark, it really is an easy, a low entry barrier in processing big data. All right. So now let's proceed on to a quick demo of all the services available. Let's first start with the GitLab. Let me show you what GitLab looks like. So remember, all of the services are available in one platform. So this is officialstatistic.org. So if you are going to get the services, you'll be provided one account, and you just need to sign in, and you'll be required to, it's a two-factor authentication. So you just need to input your Google passcode. And then, so we get to this big data platform where everything is located. And let's try to go into the code services. So when I click on GitLab, I get redirected to the website for GitLab. And I don't even have to log in anymore because it's only just one login for all of the services. And I'll just give you a view of all of the projects that I'm currently working on. So we have, right now I'm part of 5 groups. In here is our repository for all of our collaboration work within the AIS Task Team. And then I've also created, for example, all of the notebooks that will be used in the demo. It's all saved in this repository to buy Expo. So this is our collaboration tool. All of the people working, all of the people part of the UNGP task team. So we have there Marky and Gabriel. So we collaborate on this repository. All right, so that's the first one. It's the code repository for our code collaboration platform. All right, so the next one is the analytics workspace. So let's try out the task. So when you enter Jupyter Hub, you'll be given this option. So the first 2 options are the options for your normal data science work, wherein you don't need a lot of computing power because you're not working on big data. So it comes in with a lot of the usual packages for data science, and then even if say you want to work on Python or Julia or R, all of the environments are already available for you. So let's just wait for a few seconds for it to load it. So while in there, the other option is the one that has the data mechanics gateway. So later I'll show you how to load the notebook that is connected with the data mechanics gateway. Let's just wait for this one. I'm working on, I use Jupyter Lab because I'm more familiar with working with Jupyter Lab, but if you want to use Jupyter Notebook, you can also do that. So again, in here, we're accessing a cloud-based platform. There's no installation required on my local computer. I just need to access the environment already available, already provided by UNGP. And just to give you, just to show to you that the packages usually used by data science is already available. You have pandas, sklearn, and so on. All right. It's important to always shut down your kernel when you're done. So next, I'm now going to show you the one that's connected to data mechanics. And we do that by, I'm gonna also show you how to do it. Suppose you have a local installation of Jupyter. And to do that, my local installation of Jupyter is through Anaconda. So I'm using Anaconda prompt, and then I'm entering a code that calls Jupyter Lab, but I'm telling Jupyter Lab to enter it via data mechanics with my personal token. So you have to replace this with your own token and then press enter. So when you do that, you'll be transferred here. So in here, this is from my local notebook, and I have connected to the server of connected to data mechanics. And we do that by, if you look at the data mechanics dashboard, we have here a kernel running that is under my name, right? So this kernel has Spark already available, and I'll give you a demo on how to extract data from it. Right. So far, hope everyone is following. Okay, so you have to remember the AIS data structure first. From what was said earlier, AIS is saved in S3, and the bucket to access it is this bucket, and then it's saved on a weekly basis, and then the files are in Parquet, and it's partitioned using H3 index resolution 0. So for example, we want to try to
Cheryl, sorry, maybe you can zoom in your screen.
Okay, wait, let me
so
try.
we can see better. Thank you.
So for example, we want to try to extract AIS data during the Suez Canal blockage. So remember what Gabriel said earlier, is that you want to divide and conquer. So what we need here is the exact location of the Suez Canal blockage, and then the exact period of when it happened. So let's start with the period. For the period Suez Canal happened, the Suez Canal blockage happened from March 23 to March 29. So since the data is saved on a weekly basis, we want to get the week number of this date, and we're using pandas to do that. So in here, the dates March 23 to March 29, and the week number for that dates. So what we're interested in is the week number, and then for this demo, I'll just use 1 week. So we're going to try to download the data from March 23 to March 28. And then we do that by simply, it's really the simple code. So Spark, Parquet, and then we input the week number. So when we submit this instruction to Spark, you'll notice that if you're familiar with using Spark, you usually need to create a Spark session. But with the UN Global Platform, we don't need to create a Spark session because it's already loaded for us with the kernel. And then you'll notice that when you go to data mechanics, currently there's no CPU assigned, but it's still loading. So later, what it does is to assign executors for the instruction that we have just submitted to it. So it takes a little bit of time to assign some executors to the instruction. But basically what it does is to read everything that's in week 12. Okay. Let's see. I think it will take some time for this period for it to load. While waiting for that, we should be able to get the count of our observations. Once it's loaded, we'll be able to get the count of our observations, which is about 11 million. Data mechanics. So while that loads, I'll give you a way on how to focus the extraction to a single location, just like what Alex has advised earlier and what Gabriel has said earlier. So they told us that we don't really want to read everything on the AIS data set. What we really want is to focus on one, is to first filter based on one index. And we do that by through H3. And so if you wanna say download data from Suez Canal, what we do is to select a point in Suez Canal and then get the H3 H3 index resolution of that point. So if I run this, I'll be able to get this H3. And then what I'm gonna do is I'll add that information in my Spark construction. So add from week 12, you add the H3 index field partition, H3 index 0 information. Okay, so we are now assigned four executors for the instruction that we have sent it, which is to read the data. Okay, so you'll know that it's finished when it's not loading anymore. So we have finished reading this data. And now let's try to count the number of observations from everything within week 12. So this is another instruction sent to Spark. And then you'll notice that it's possible that 4 executors is not enough. So what data mechanics will do is to scale this up. And okay, so 4 executors is enough, and it was able to read 118 million rows of information. So that's something that you cannot handle with your own laptop. And fortunately, we have UN Global Platform, UN Global Platform's infrastructure for us to be able to handle this amount of data. Let's try to work with it using H3. So this is the point that I'm selecting. It's in Suez Canal. And then that point is located within this H3 index. So again, what I'm going to do is to add that H3 information when I read the data. So you can see this is a lot faster now because we're reading a smaller amount of data set. So from 100 million data set, you're actually just only interested in about a million rows. Let's try to view the AIS data. This is a schema. So if you're familiar with the schema of the data, so it gives you the information, all of the information available. It's more fun to look at the actual values. So let's try to see one row of information. So remember from Gabriel's presentation, we know that all of this info, some of these are manually inputted by the staff of the ship, and then some are automatically transmitted. So for example, we have destination. So destination is a manual input. There's actually supposed to be a standardized way of putting your destination that gives information on the next port of destination, but they didn't follow it. We have information that's dynamic, such as the longitude and the latitude, and heading, and this is the time information that is based on the received time, and then also a computed variable prepared by Alex for us, the H3 index resolution 15. Right. So far we're good. So this is an example of one information of AIS data. So it's let's try to verify if we were really able to collect all of the data from the period that we're interested in. So we're using PySpark, still using PySpark, and then now we're running a function that computes the minimum date and the maximum date of all of the data set that we have read. So this verifies we have collected data from March 22 up to March 28. And then one last is that I really like to visualize the data that we get. So what I'm gonna do is now to transfer the information into Pandas so that it's we can easily process it. We can transform it to Pandas because we have reduced the amount of information we're reading to just 1 million rows. So in here, I'm just transforming it to Pandas. I'm getting a sample of 10,000 data. And then I am ending my Spark session since I'm no longer using this Spark for it. So far we're following with the demo. I hope everyone's following with the demo. It's all pretty easy for the users. What's happening in the background is that it's assigning executors for the instructions that we have sent in. As you can see, I have ended the Spark session, so that's very important since I no longer need a Spark session. You can see on the data mechanics dashboard that there are 0 CPUs assigned. And then now let's try to visualize our data using volume, shapely, and HD. I've created helper functions for the visualization. So this is what the small data set looks like. I've only gotten the timestamp, latitude and longitude, and also computed the different indices, H3 indices for each point. And then I'm generating a map for you. So remember, we downloaded all data available within H3 index 0. So these are all the AIS data shown as a heat map where it's darker or closer to red. That means there's a lot of AIS data transmitted in that area. So there's probably a port here in the Suez Canal. Since there was a blockage, there will be high AIS data here, entrance at Port Said, and also at the entrance from the south. And then suppose I want to focus on, say, just this section, I will do H3. So if I do resolution 1, I just need to get H3 in this H3 index. I'm not going to be interested in all of the other AIS info. And then suppose I want to do finer resolutions, I'll go to resolution 4. So each point is assigned an H3 index. So what I'm going to do is I'm going to collect all of the indices that are covering the area that I'm interested in. And then that's what I'm going to process after. Right, so that's how you extract data. And then when you're done, this is very important. You always have to remember to shut down your kernel to ensure that there will be no more executors assigned to your task. So now that we don't have any kernel assigned, you see here that the status will be completed. And just shut down your Jupyter session. Great, that's it. Are there any more questions? Do you guys have questions for me?
Thank you, Cheryl. So this is just a very quick demo that, in fact, it's live demo. And I'm always worried in the live demo because
Yeah.
everything that is wrong always happen during a live demo. So, but the system seems running well, right? So the system is able to filter, extract the data, and plot it in the map, right? So if Cheryl can do it, right, every one of us can do it also, because we also already share the code with you, right, in our Google Drive. So the question is that you cannot just run it in the, your local notebook or your Google Colab, right? You need to have connectivity to the backend Spark cluster, right? So this is something that we're going to tell you how to link this. And of course, the demo PowerPoint also, everything that that you need is already shared in the presentations. Any questions? So this is just to show you, right, from this 40 terabyte you run, and we have the result, for Mediterranean for how many minutes you have presentation, like 15 minutes, right? So you already have a result. And I think this is also the power of collaborations, because you don't need to start from scratch, right? The community on the AIS Task Team, we develop a lot of codes already. So you just need to, thinking what else you can do, right? So you don't need to worry on how to extract the data anymore because it's already done. How to filter by H3 index has been done. So now you can go for more advanced things, for example, maritime emissions, right? Or estimating trade, right? Or estimating, for example, we have a specific use case about slavery in the sea, right? The well-being of the seafarers, for example. So there's many things that you can think of. Any other questions before we go for lunch? Yes. Okay, so this is just the demo sessions, and then I do have some closing remark for the morning sessions. So in the agenda, I would like to have some kind of like discussions, right, with virtual and also in person, right? What we can do to work together, right? We already have mentioned that, so we offer this platform and the data for you to use, right? So we have the data, we have the platform, but we don't have enough people to use this. And this is something that you can come, right? So you don't need to worry about the data, you don't need to worry about the preparation of the data, you don't need to worry even about the cost of computing, right? This has been handled by us. You just need to worry, to assign someone to work on this, right? So this is something that we can do. And this is also something that is important because every region, every country, they have a specific needs, right? So for example, when we work with Panama, for example, Panama is very concerned about the Panama Canal. That may be not the same concern in the Gulf region, for example, right? Egypt may share the same concern because of the Suez Canal, but UK will have a different use cases because UK is basically an island, right? Therefore, goods coming in and out through maritime is very important. But I also understand some country is a landlocked country, and then you say, okay, what do you need this for, right? So landlocked country, they will get the data from somewhere, right? For example, Burkina Faso will get the data from Benin, which is the port to go to inland Western Africa. So you can monitor the activity in Benin, even though you are in Burkina Faso, right? So this is something also that you can explore. And I really would like to welcome the use case as much as possible. And then we can have a proof of concept, we can code together, we can share. Something that is important that we can do is that since we have a strong community on AIS, your codes would be peer reviewed. The quality will be peer reviewed, right? So that it's not that you are alone, but you have a community on this. So this is basically the future directions. So we have completed like all of the preparations to make the system stable, and also to develop some kind like a training courses for you to start. Now we are in the next step that we need your active collaboration and participations. Use this platform. This platform is basically 24-hour. You don't need to wait until my time zone come up. You are welcome to do it. And I think so far so good, right? There is with this platform for now we don't really have huge interruptions, right? You can always come and you go and that's it. It will take some time for you to learn and to use, but I guess that if you do it every day for 1 hour every day, maybe in a few weeks you will be an expert in AIS. Right. Anyone would like to make some comments on the future collaboration and future work? And of course, I also need to underline that we do have a regional hubs, right? UAE, in Rwanda, in Brazil, in China. So we can collaborate on the use cases, for example, right? So a certain region will focus on certain use cases, maritime emissions, for example, so that you can explore the algorithm, you can harmonize the method and so on, and then we aggregate it later on to the world level. So this is something that we can work together at the functional level. Or another option is that if you have a specific data sets, right? So maybe we can link these data sets, right? So you have a specific data set that's applicable on your regions. And then when we analyze this, we can link them together, for example. This is another option. But of course, having a new data set is always not easy. We do have already some database, data sets and database here that you can immediately use. But if you can bring additional data sets, it will be much appreciated. Yes, go ahead, sir.
So the pandemic, well, thank you. I think some changes dramatically happened in the, like I can see here, 8 choke points for oil trading and shipping, like Bosphorus Strait and other choke points. So due to the pandemic, maybe we don't have an updated data for that. So instead of having brand new data from scratch, we can update the available ones.
Sorry, what data you're talking about?
I'm talking about the ships, the choke points, movements of the tankers, of the oil tanks.
Okay.
So yeah, you put a very interesting question. And one of the additional benefits of AIS is like you can retrofit. So you can go back in time and process that information. If perhaps you had that gap that you're mentioning, and it is important for you to identify perhaps what the pandemic did, then you can just go backwards in the AIS raw data, process it, and get it as it was today, right? And then you get statistics for that time on. So additional benefit.
Comparing, maybe comparing the data before and after.
Absolutely. We got an interesting case, at least in the Panama Canal. We saw already the effects of the pandemic.
Okay.
At least on waiting times that you mentioned, choke points were an issue. The Panama Canal by itself is a choke point.
Yeah.
And you have like 3 times the waiting times at times of pandemic. And then it balanced. And there still is creating an effect on the global economy, shipping being the motor of global trade. So it is important, yes.
Okay. Okay. We can maybe communicate later. Thank you.
Yeah, thank you. Thank you for the comment. Anyone else from the floor? So something else that I would like to mention is that, so we do have AIS. And AIS is a geospatial data sets, right? And we know that there are other kind of geospatial data sets that we can put in our platform. So we're talking about mobility data sets, for example. Right? So we can also somehow access this data and put it in the platform. So we know also there's a flight tracking, ADSB, right? If there is a good use cases, we can also put this information here. And the platform that we have, that Alex has described clearly in the beginning, this is a generic platform. It's not for AIS. And we can install any libraries we know that you want, so that we can apply it to any use cases. Right? So if you want to use deep learning, we install these libraries. So this is a generic platform that we can use for any kind of data set. But maybe we can specialize more into mobility, like transportations, railroads, trucks. This may be important. And of course, the question is that how can we get all of these data sets, right? But that's secondary. So we'll start with AIS. We build up the skills, the data science skills in processing geospatial informations. If you are very familiar and comfortable, we can go to beyond this, right? Luckily, we have a community, we have a platform, we have the data, and then I think that we can move forward together. So if you stay, you want to talk? No questions. Yeah. Okay, we have a questions from NS. I will read it. For NSO, in the midst of building their own big data infrastructure, it is possible to get kind of shared experience of your journey to building and implementing AIS. Yes, of course, right? So if the NSO would like to build the big data infrastructures, I mean, we can share our experience. The main of the challenge for us is we should have a good scalable system, but at the same time, the cost is under control or cost efficiency, right? There are a lot of off-the-shelf applications of Spark, for example, that you can just go and pay, but it will be very expensive, right? So our current solution is cost efficient. We need to do some kind of a legwork to make it work, but it's very cost efficient, right? So I mean, of course, we are happy to share all of these informations with you. Thank you. So in the afternoon sessions, right, in 1 hour from now, maybe we make it like 1:15 p.m. So we will have coding sessions, meaning that you need your laptop, right? So we will help you installing the Jupyter notebook if you don't have it. We will help you to connect your notebook to the backend AIS server, Spark clusters, so that when you run it, you can take this advantage of this distributed computing. And we'll go we'll help you also to run the code one by one, just like what Cheryl did on this counting ships, so that you can feel comfortable. You can do it, right? And then you will see the result immediately. And then later on, you can try to change the parameters. For example, instead of Mediterranean, you go to Caribbean. And you try to figure it out how to define the H3 index on Caribbean and so on. So I hope that at the end of the sessions in the afternoon, you have confidence to use this, because I think this is one of the gap that sometimes we don't feel that we can do it, right? But we will prove you wrong that in the afternoon, at the end of the day, you will be able to extract this AIS information. You'll be also to plot it in a map. And Gabriel will have a specific notebook that can calculate maritime emissions. So for fun, we can, for example, calculate emissions that going through in and out on a certain shipping location, right? I don't want to give you 100% guarantee. I will give you like maybe 95% guarantee that you will run the notebook. Because my issue is that we may have a challenge in installing it in your local computer, right? In the global platform, there is an option that you use the Jupyter Hub. This is within the platform. The problem is that it's quite secure and require multi-level authentications. And I'm not really an admin on that system, right? So that's why I prefer to use the local Jupyter Hub, connect with API key, and then we run it from there. But if you have any issues and anything, we can always continue working later. So thank you again for your attention. Thank you, Cheryl. Thank you, Gabriel and Alex, right, for a nice presentations, useful presentations. So I will see you in 1 hour at 1:15 p.m. here. And for the virtual participants, you are welcome to join us, right? So the Zoom meeting will be broadcasted. If you have questions, you can use Zoom, or you can also use a Slack channel that we created. Thank you, everyone, and have a nice lunch. To run some codes, right? It's a coding session. So it's that you don't require to do coding, but the minimum is that you should be able to run the code that has been there, right? And of course, later on, you can modify certain parameters, you can add here and there, and it's really up to you. So the first thing that we need to do is to set up the connections, because we're going to use a local Jupyter notebook in your PC or MacBook. And then we will also tell you how to link this with your API key, right? So if you haven't joined the Slack channel, so I suggest that you join now, because we will put some of the coding and codes there also. And we can we can also mention it in the Zoom chat if necessary. Okay, so Gabriel, maybe you can guide for the installation first.
Yes, of course. Yes, welcome back. Thank you for staying with us. I got to address also to the virtual participants. Please remember that we're closing the Zoom session in 5 minutes, meaning we're gonna lock it down and we're gonna stay with the people that is inside. Please remember those friends of you that went out, let them know that they could come in the next 5 minutes or such. So now we're gonna have a walkthrough in how to install this in a local computer. Can the people in here raise their hands if you have a Windows machine? Yes, seems that, yes. We're gonna do it on, not Windows machine, Mac or Linux? Only one, so Alex, that's yours. That's your customer over there. Okay, all the others, please try to follow me. I uploaded, if you have access to the Google Drive, there's a file or there's a folder over there that says Jupyter installation. I have to ask this as well. Please raise your hand if you have installed your Jupyter already. You have no work, Alex, yes. There is not a problem. It's very easy to follow through. We have a very clear, or try to be clear on a step-by-step setting to install that. Those that haven't installed a Jupyter, do you have access to the Google Drive with all the files? I put it like 2 or 3 times already. Let's put it again, yes, sure. Yes, do we have access? Have you opened it? No? Okay, yes, how do we get a link to them? By mail? No? It's gonna be difficult. Do you have access to Zoom, for instance? Let's. Okay, so we're gonna solve that right now. Alex is gonna create something for us. It could be easier to access. Okay. Is it the same with you, Professor? Over here. Yes. Is it the same with you? Can you access the files already, or you're fine? You're good. The people over here, I saw some. You all can access the files, right? All right. So we're gonna just. He's gonna do it very quick. You're just gonna wait for the professor, so we can go all together, right? Okay, I got to address now the people at the Zoom meeting. We have shared with you a Google Drive link. Please access that, and if you wish, you can download the whole folder. While you do that, we're gonna wait just a bit. Yes, Prakash from the Zoom session. The link is the one just posted by Marky a second or a minute ago. Please confirm, Prakash, that you could access. Okay, remember that we are also in Slack. And we can address any other question there as well. So we're taking, we're following both Zoom and Slack. So Prakash says that he does not have an access. Okay, yes, well, try in another way. Perhaps you could sort it out. If you cannot, let us know. Alemudin, thank you for letting us know that you could access. Huh? Yeah. Emalata, thank you for letting us know that you could access. Very good. Yeah. Thank you, Yusuf. You said you're ready with Google Colab. We'll see how to sort it out. We never done it in Google Colab before, but hopefully it could go through. Conceptually, we might know how to make it true, but we never know until we do it. Yeah, you give me a link on the chat. Yes. Let me grab it and I put it here. Yeah. Where is the chat now? Yeah. I will put it in a blank document so I can. Okay, I'm going to share my screen now so you could follow another link for those that cannot access. Yes, Professor. We have a new link for you or anyone on the Zoom meeting that had problems with the other link. You can also try this one. You should be able to see the drive folder there. Well, Yusuf, yes, we're going to start with the data extract demo, right? Yes. So in that case, that's the right one. I do beg for to have just a bit of patience so we can follow through with people in here and on the chat. I promise it will not be long. I do know that there's some colleagues out on the chat group and also locally that have additional experience on coding and stuff. I do beg that we could have some patience and we could all be together. This is a learning process for all of us. Thank you. Okay, for those on the chat, Mark, you already uploaded the URL for having the gateway ready. Those that know what a gateway is, please go ahead. Yusuf, probably that's for you. You may have to link that to your call-up session. So the gateway, the main difference on the gateway, and I really beg for, I cannot see my screen over here. Just a second. Let me share it differently. Screen. Where is that? Yes, there's on the chat, there's the script for getting your gateway through for those that are a bit more advance on this one. Okay, now that we are all, or most of all, Professor, you got it? Yes. Yeah, let me go closer to you. Yeah. Yes, your storage is full. Okay.
So it's not offline.
Yes. No, no, it's not. I actually see that you got it here. You get yes. Can you zoom out because
I don't know why.
here it goes. Wonderful. So now I'm going to download this for you. Okay. Can I put it on? Can I download it so you can have it in your computer?
Sure, yeah, but I don't think you will be able to download. There's some security.
Let us see.
Normal file.
Yes, it's not very big. It's just documents and coding. It seems that it's downloading, but yeah, there you go.
Yeah.
So try to find where the file is.
I can find it here.
Yes, I will just open it for you. And perhaps, is it okay if I put it on your desktop so you can have it visible?
No
Yes. Okay, I will open this. This is a zip file. And then I will just grab this out of here to your desktop so you can easily access. All right.
Okay.
So we are ready. Yes. So you just open that one. Yes. Thank you. So you can go in this one. Yes, we have the instructions over there. In any case, I will put it on the screen as well so you can follow through. All right, guys. So there's a document. There's a folder that says Jupyter installation. We have a step-by-step walkthrough in a PDF file inside. I do beg that you could follow that one. If you have any question related to the instructions, please let me know so we can sort it out. I repeat, this is only for Windows users. So first of all, you need to download Python, of course. There's the link. That's the blue section of the first line script. Go and press on it. Allow, yes. It will take you to a Python website. This is the official website for Python, a secure website. Yes, and then we scroll down until you see something called Windows Installer 64 bits. Download it, then execute it, and let it go. True. Let it install. Just let's press in here. Oh, sorry.
You mean unpick this one?
Yes, there you go. That will allow to because you wanna do local, not like because I guess this is your office. It will have problems if you try to install to all other users. Probably they make just a user for you. Just on your computer, yes. All right, there's a question. I'm using a Jupyter notebooks. Yes, it works fine with Anacondas as well. Thank you. Very nice, very nice. Yes, Afshan, if you're using Anaconda, it works the same, right? Okay, in that case, Afshan, you can go to, you can open a command prompt. You can find that on Windows. Just type in Anaconda. And you will find perhaps an option below apps or such that says Anaconda prompt, PowerShell, or Anaconda prompt with the black square icon. Let me know if you can open that one. Yes, are we good out here? Yeah, you seem to be handling, right? Yes. Wonderful. Yeah. Professor, have you installed it? Yes, you're on their way. Very good. Yes. Close it. Yes, you have it installed perfectly. Very good. So we now can process to step number 2. That is that. Let me remember what was step number 2. I will zoom this in. Wonderful, Prakash. Thank you very much for the confirmation. So on the Anaconda prompt, you're only going to copy the script that Marky uploaded.
However, where it does says API key, you're going to introduce the API key that you generated from before. Were you able to generate the API key before? Please confirm. Afshan, yes, you will replace the, check out the script from Marky. There's a section that says API key, all in cap letters. You will introduce your API key there. Okay, Afshan, you have to generate it. I will send you an URL so you can generate it yourself. Just give me 1 second. This one. Coming in, yes, just a second. Afshan, check out the chat. Wonderful, Prakash. Good news. You have generated your keys. So, Afshan, you can use the link that I just sent, put it in your browser. Either it's Google Chrome or Firefox or Edge, it doesn't matter. And where it says your email, you're going to introduce there your email. That should brings you to a new website where you will have your API key. If you want, you can copy that API key in a notepad in your computer or somewhere you can use it back and forth. Trust me, guys, installation is still the most difficult part that we will handle today. I don't want anybody to get afraid. We're going to get this together, and I assure you, you will run the code at the end of the day. Or at least any one of the codes or some of the codes. Okay, Professor, we can do the next step over here. Professor, could you follow up as well? Not a problem. Let's sort it out. Yes. Oh, I just put it out. No problem. Let me show it to you. Just a second. Yes, Afshan, thank you for the question. Where do we use the key? The generated key, you're gonna put it in a script. I will copy the script to you once again on the chat. Okay, please note that that script has a section that says API key all in cap letters. You replace that one and then introduce your specific API key in there. Okay, Professor, here's the link. Yes. For those on the chat group that are already advanced on it, you can go through and try to test some of the codes that are out there. I got a disclaimer to do. There's one of the codes that for vessel emissions. Please don't go into that yet, because that was prepared especially to have errors so you can troubleshoot them and fix them. So that means that if you try to run them, that will not go through. I got the battery on my side and I will share it with you later on. So the version that you have on that folder on vessel emission does not work at all because we have done it on purpose. We have set in some errors so you can find it out within that session. So you can go on the AIS demonstration, Jupyter notebook, and you can open that and play with it and check it out and how it works. Disclaimer. You can load the Spark session once, and if you're not logging out, you can just keep it open. Otherwise, you have to close the Spark session by spark.stop and then parentheses. Okay, so that's for you that are a bit more advanced to get it through and don't wait for us too much. We will get through the examples in a moment. Okay. So we have confirmation that Anaconda works just fine. So for those that it doesn't open, you can try that option as well. So that works as follows. For those that have issues trying the pip install, the pip section, you can try downloading Anaconda. You go on Google and you just type in Anaconda as a snake, Anaconda download. So you can install Anacondas and you can download it and install it. Anaconda works both same good for Macs, Linux, and Windows, so it shouldn't be a problem. It is downloaded?
Yeah, because the pip did not.
Okay, that's fine. Just let me try something. Can you open that one again? Sure. The command prompt? Yes. For some reason, it's not detected Python. Oh, this is Python already.
Yeah, it is. Yeah. So that's.
Okay, can we try the Anaconda? You're downloading.
I'm
already.
downloading.
Okay, let's install that and wait. Yes. No, no, no problem. No problem. We're patient enough to get through. Yes. Okay, seems that we have people loading the data already. Are you doing okay? Not working? Yeah. What happened with Anaconda? Why it doesn't download? Okay, it seems that we have this access to this one, but you have to ask the people in here that they know. Oof. The what? Prakash, you said that you have Jupyter already. Yes, if you have Jupyter, you don't need to download anything again. You can just go through Jupyter and open it. It is better to do it through command prompt because you can just type in the gateway directly and it will opens up directly. So you can skip all the steps until having Jupyter and having the gateway. So Katia, you have tried Anaconda PowerShell and Anaconda prompt and CMD, and none of them works. So well, you actually, yeah, you don't need to open the Anaconda itself. Have you tried just typing in Jupyter Network to see if it works? Just to proof check. It's not gonna bring you into the cluster, but just to proof check. Thank you. Are we doing okay, Professor? Yes, we're getting closer. We're getting together. Yes, no problems. All right. All right, so. Yes, yes. Yes. Is this console, I apologize if I remember, is this console working? The one that you have here? I can see that this is Jupyter, right? So this works perfectly, right? So that's localhost. Perhaps it's trying to find on the same port. Are you capable of closing this one and starting from the command prompt? That is going CMD, but closing this session first. That could be an issue. Yeah, where is this coming from? Yes. Yes. Because it's this is a GitLab. Yes. Let's try something different. Can you just please type in, go on the Windows and type in Anaconda? Can you open this one over here? Yes, let's try that one. Can you please type in Jupyter Notebook only? Just Jupyter Notebook. Yeah. And then okay, works wonderful. Okay, now can we close the tab, please? I was just proof checking. Yes, that one. Yes. Can we go back to the prompt? This one. Yes. because it seems to me that this is actually work. Can you just? Oh no, that's my picture. Sorry. Not that prompt. You can close that prompt. The other one. Yes. And you just press Control C. Control C will stop the session. This session. Yes. All right. Now, can you copy please the whole script, including your API key? It should work now. Yeah. Let me know if otherwise. Yes. Professor, good? Did you install it? Still install? Yeah, it's quite a, sometimes it takes a while. Yeah. So yeah, you might have to open that to check. Okay. Okay, what's going on? Sorry, yes. Okay. That's going through? But you got access, right? Now you can download. Yeah, just download. Okay, very good. It seems to be in already. Yeah. You choose your kernel, it's running? Yeah, but I'm waiting for it. Yeah, it takes a couple, if you want a coffee, it takes like 2-3 minutes. So. Actually, that's part of the instruction. Okay, those that have access and have opened the kernel, you may have identified that nothing is running yet. Yes, the system by default takes a couple of minutes to bring your connection through. So what I would recommend is that those that are accessing the kernel already, to go for a coffee, you can take a glass of water or something and come back in 3-4 minutes. That's the time that the login, approximately the login takes. Okay? So don't worry if it's not running straight as soon as you open it. You have to wait 3-4 minutes for the kernel to kick in. Remember, this is an environment that has several users, so we need to be patient in the sense that the system needs to do the things. It takes a bit of time, but it does the things properly. It's going. Okay. I'm not worried. It's going. It takes some time. AIS what? Yeah. Okay. For those that are ready and have installed their Jupyter, has gotten into the Jupyter notebook, has selected the kernel as per the instructions. Please go and open the file called AIS Vessel Extraction, I think. AIS Extract Demo. It's also in the folder. Yeah, give me a second. No. Okay.
Gabriel,
Cheryl is promoting another one. I think you can open
if
any of those.
I'm gonna go first, am I going to go first for the
Okay,
demo?
so you can open the AIS Data Extract Demo or the Ports Indicator Demo.
Yeah.
They both work properly. They should go through. So you open that one, you select your kernel, and wait the kernel to open, and then you can start running things around. Yes? Yeah, you have to, let's be patient. It's like you have a lot of people in. It should turn white when it is ready. Yeah. Oof. Yeah, Cheryl is in charge of is gonna take charge of the assume the Zoom shot. And the kernel? Yeah, same time. It's unusual. Yeah, it will send you a check. Can you please let me know when you got it through, please? Oh, you got it through? It went off again? Okay, be patient, be patient. Be patient, it will come through. Okay, installing. See, it's being installed. Okay, working done. Okay, is there any other tab open there? Can you check? That's the only one? Because it says work is done. Oh, it's not, that's not a big issue. Okay, I guess we have to wait. No problem. Okay, now it went through. It is ready. Can you try running just the first line? Beautiful, it's working. Just try to play back and forth. Try to read out also the description so you can understand what's the logic behind everything.
I don't understand. What is this exactly? This is the number of weeks?
That's the week number, yes.
Ah,
So you transform everything to have the week number. Sometimes when you are aggregating data, you want to aggregate it weekly. And that's pretty useful because you can group by that column. Yes. Okay. Professors are waiting, yes. We're pending. Okay, this becomes initial now. All right.
You're rejecting. Does that have to include the path?
Yes, it's like you need pretty much what you have to do when you install Python. You have to create the environmental path, but it's not. Seems that it hasn't created. So that's why when you type Python, it should like, woof, it should take you there. Yes, but it's not working.
Maybe I'll uninstall it and reinstall it again.
Please, if you could, yes, yes. This is becoming problematic over here. Oh, you just need a bit of massage in order to go through, yes. Yeah. Yeah, you don't need any of that. All right, can you just go in here and just type in Anaconda? You should be able to find something called command prompts. Yes. Okay, not that one. No, sorry, it's not that one. No. No, wait. No, cancel. Ah, that's setup. You don't want setup again. Just cancel. Just cancel. No, because it will start installing again. Yeah. Where's your? No, it should have. Where's the installation? Do you mind? Can you restart the computer? Is it possible? Yes. Yes. Thank you. Ready? Oh, installing. You ready? You can just go directly. Is it good for you? You can also load the port indicators. No, we did. The two files that are there, you can open as per Cheryl. That's what Cheryl mentioned. Professor, are we okay? Is it working? Oh, yes, perfect. Very good. So month and days afterwards, yes. Yes, well, professor needs whole installation yet, but I guess we can just go for. I told Cheryl that she can lead the session. Oh, sorry. Well, I forgot. I got the last one you have on.
Yeah, maybe not week 22 week, whatever one. Historical data, so it's.
So Abdullah, you got a question there. I'm not sure. Can you expand on that? What link do you need for Google Colab? Like the regular Google Colab or? Ah, yeah, it's you. Okay. Yes. Like you. So pretty much they have the script for the code for you read on duplicate. So you have to do it already? Or I think I see it's showing some. So we tested already that after you do that, you go to like what? Okay. You have to get ready to go. Perfect. Let's go to the installer again. And you just copy, yes, go directly to the folder to see what we have. First one, we will find the command from there. So can you go back to exactly and perhaps try to delete it? But probably will not be able to because you have not validated the thing. Do a spreadsheet. This is the only part. Don't worry. After this, everything goes like smoothly. No, don't worry. Don't worry. You have several. That's why we're several. That's why we're several. You don't actually need to do all of that, but well, if you want to. Okay, you got everything. No, but try opening on the front, so just type in the. You already have the KPI thing. So go and install the API. You have what? You have to see a chat group on the Zoom meeting. Yes, I don't know if that's there. No, but those are the other.
Okay, that's probably it. You have, yeah, probably you can do the email that when they send you that. I will- So we have a thank you. Ah, yeah, do the AIS
But I don't think you're going to.
Yeah, it's okay. Just because actually my script run until last week. If anything was changed after that,
No, nothing is changed.
okay,
We share our schedule around it.
you don't lose.
Okay, since everyone is running,
Are we gonna retake it? Yes. So go on the window. Yes, and just type in on the corner.
Okay, it's running in local.
Yes, I want it to run on the front. That's the front and the corner. Right? Yeah. Just type, yeah, open the. Then you have the URL, right? What's the Jupyter Notebook Gateway API? Put that in. There's a section we have to implement the API key, the personal one, and that's section open. You need to have that API key. Have you generated an API key then? No, okay, we can do that easily. Go on the screenshot. We have posted there. You can copy the link. You have it in the chat. You don't have the link. You don't have follow up. Yes, I actually didn't put the how to generate the API of the structure.
oh, we can give him.
We'll give you an API to how to generate it. Yes. So maybe we can show. Okay, let's try something. You can fix that later. Ah, you went out. Yes, reinstall. Reinstall. No, not fix. No, I think this should be good. Okay, Professor. Now, and we need API as well because I think. Oh, yeah, do you have API? No. But well, what? You got class now?
I have class for 1 hour. I will finish it and back. Sorry for that.
Okay, I will give a presentation on emissions, Professor, probably in about 45 minutes to 1 hour.
Oh, really?
Otherwise, you could just follow the presentation on the PowerPoint. Is there on the folder?
Just 1 hour.
Yes. Okay. Now, new error. No, take out that one.
Take out that one.
Keep that
Register.
one. Install. Yes. Fingers crossed.
Go to Google Drive.
We have no access for the URL. For the API.
This one? Yeah. Copy this one and put your API.
But I think
What do you mean you don't have access?
because some people is still missing the API because they are
Yeah,
not.
I can give you API.
Okay. You get the API, right?
Yes.
Is it working?
I'm now
Just typing it. Okay. I think you're already working on that. I remember. Yes. Yes.
Yeah, of course. Yeah.
How can I share it with you?
Slack or it's too long.
You have to give it to them, right?
Work
You have to give it to them, right?
to the professor back there. Yes.
Do you have a
USB key?
no?
I do. I do. Sorry. Yes, I do. It's a memory, but it works. Okay, guys. Meanwhile, if anyone is having chocolates, there you are. I think that is just served because I'm taking your very famous Camel chocolates back home, so there's the exchange. Chocolate? Well, almost. Hi. Welcome. Oh yeah, wonderful, wonderful. Are you checking out if your AIS receiver is working or? But yeah, you don't need to. But you know, it's like sometimes more. Well, you say already you want this to be like from end to top, like all of your development. Okay. Yeah, yeah. Because what I do, actually, I got a receiver, but I didn't do it myself. Marine Traffic just sent me an Raspberry Pi whole closed system and the antennas, and I give them like access to that information. So pretty much I install it for them. Yeah, yeah, yeah. The other part, they gave me access like for free. Not as much as what we have in our platform, but they're good enough to do what you do. Yeah, yeah.
I also put
It's problematic, yeah.
I also put the comment prompt. So
All right, thank you. Oh, yes, hello. Next step. Yes.
So
what-
here,
so-
it's I have a few drives.
Yes, okay.
So
I would say
will I
that
need to,
yes.
like, will I need to like install Anaconda again?
No,
and, like,
not at all, because those are hard disk, right? Just,
Yeah.
may I, just a second.
Yeah, sure.
So it doesn't go up to that position. So perhaps what you could do is, do you know what your user is?
Yes, it's the first one.
The first one. So what I could propose is that, do you have the folder? You remember the folder that you downloaded? The zip folder? Do you know where it's it?
Yeah.
It's on downloads in desktop, or, the first one, the one that has the instructions and such. Yes. Let me do that. Folders.
Oh, it's
This one.
here.
Yes.
Yeah.
So this is on. Can you please download this one?
Okay.
Not just the file. Sorry. Go back and download the whole carpet.
Okay.
Perhaps you can just go back once more. Download the whole carpet. Put it on downloads or on desktop, whatever you like, and we will find it from there. Should not take so long. It's a zip file. You have to extract it to the same folder. Mhm. So you can choose from here. You got nothing there? I remember this problem, and this is a problem with the certificates of your browser. So pretty much it's like they updated, so you need to update your browser if that's an option, but I don't recommend that. Don't go through there. Oh, no, no. How do we bypass it? I'm pretty sure it's the certificates on the browser. Yeah, on there put your API. Perhaps it works straight. Okay, this is Safari, right?
I'm not sure whether it's going to give AI.
We have given you a, yes, that one, yes. Copy all of that, put it on your browser. Yeah, let us see, let us see.
I was thinking that too.
Sitting in the background here, waiting for it to go next.
Alex, do you remember the problem that we had before with no kernels?
Yep. Is it software? Is it?
No, no, it's not.
It was Jupyter Notebook, not. Yeah.
The way it wrong the first time around seemed to know.
So it worked well the first time.
No,
It hadn't worked at all.
Nothing changed. Create a completely new environment.
So we have the suspicion of telling him that it's certificates on the browser. That you have to update it, but it's not.
So you're on this network now, or are you still on the? You moved it. To this network you cannot connect. Oh.
Okay. Seems like. Okay, next. Next. Just let it, yeah. Okay, so now can we go to Windows? Anaconda? Oh yeah, come on. Sorry. Sorry for yes.
Now
On desktop?
it's not in desktop. I don't have admin.
Okay.
It's here now.
Okay, just open it.
I think maybe I need to unmute it.
You need to unmute it first. Perhaps put it on the same folder where it is.
Nothing's messed up, but
You know I got that problem, right? You know how I solved it? I changed computer.
well, I guess flush
watching the Mac operating system solving everything, but too much.
Yeah, this seems to be running okay. Um, Cheryl, if you want, you can start sharing and presenting the notebook.
Okay.
So our
Okay.
friends virtually and locally can follow through.
Yeah, I'll try that.
At least locally, they had been playing with the notebook already.
I just I just need to open a new session because
You can
my
tell me your
current
back
session
on the
is
chat
loading.
if when you're presenting, Cheryl, if that's here. Stop share my screen.
I have
And
to
Cheryl will start sharing hers.
I
Okay,
have
Cheryl, we can
to
see you. It's a bit small for our side, but I think that people could follow through their own notebook, so that's okay.
I need to set up something first. Wait.
All right. Very good. Thanks.
Because this has been going on for a
Okay,
long
guys.
time now.
You wanna follow Cheryl?
So this has been going on for a long time now, so I need to restart my kernel. It's gonna take a while. Wait, I'll just restart my kernel and then start sharing.
Cheryl, can you please speak up a little bit? At least locally, we have issues hearing you. I'm pretty sure
Okay.
that online people might have it easier if they're using headphones, but for us locally, it's kind of, we have some.
Oh, okay, okay. So I need to restart my kernel because this line of code has been going on for quite a while now. I have to restart my notebook and I think it's gonna take a while. See. But for those that were able to log in and load successfully a kernel, they may want to try the port indicators demo. And then try to load everything. So you'll know that you'll be able to load if this becomes an empty circle. So it should show here that kernel is idle. So when you have done that, try to work on these codes until you arrive in the first question. And then if you're able to arrive at the first question, anyone who's able to answer the first question, they can just share to the participants while I load my kernel. So anyone able to arrive up to question 1? Alis na kami. Sabi ka, lipat-lipat lang. Lipat lang. Sasain na lang. Okay, I think I found someone who was able to answer the first question. Right, 15 million, that's right. Okay, I'm gonna try something new. So in Kyungchar, the first one who was able to answer, can we share your screen if it's okay? And then let's try to go through the notebook using your notebook, if that's okay with you. And then I'll guide you all throughout. Yep, yours. if it's okay with you, because I am unable to load any new kernels. Right, okay, perfect. So the first one, let me just give a brief overview of what we're doing. So can you go to the very first part? What we're trying to do here is come up with port indicators for. So what we're trying to do here is to come up with port indicators for Cape of Good Hope. And why we want to do that is we know that there was a blockage there was a Suez Canal blockage, and there were actually reports that some vessels rerouted into the Cape of Good Hope route in order to avoid the blockage. Let me just quickly share something. So I'll do the sharing first. Here. So this is an example of a map I generated using AIS data. And from the map, this is Suez Canal. And this is an example of a vessel that was supposed to go to Suez Canal. So you'll know that because the destination is EGSUZ, so that means Egypt Suez. So it's supposed to go to Suez Canal. This vessel supposed to go to Suez Canal, and then rerouted by March 27. So when it rerouted, it went through the long route. So instead of going through here, it went to the long route around South Africa. And what I'm interested at is that I want to see here in South Africa, there's a port here. If there's any effect on the port Cape Town because of the vessels that rerouted due to the blockage. So that's what we're gonna try to resolve. Okay, let's see if it works. Okay, still not working. So right, let's go through your notebook again. Can you show your notebook? The next thing that you have to do after that is to convert your Spark data frame. So that's raw DF. We're gonna convert that into a pandas. So can you show your pandas data frame? That's DF, the DF data frame. And then just try to show what it looks like. DF.head. Can you do that? Is there anyone working on my notebook? Anyone currently already working using my notebook? All right. So what what's happening now is we're converting the Spark data frame raw DF into a Pandas data frame that we can easily manipulate. So after that, make sure to stop your Spark session with the Spark.stop code. Okay, so that's gonna take a while because a lot of people are working on the same thing. Can you also prepare the rest of the code? Copy paste all of the rest of the codes while we wait for it to convert. Oh, okay, we're done. Since we're now manipulating using pandas, we can end the Spark session. So that will be fast. And then now let's try to visualize what our data looks like. So we're gonna use volume for that. To do that, I've already prepared a point in Cape of Good Hope. That's the latitude and longitude points there. So yeah, so running M, you'll be able to see a heat map of the 1,000 sample AIS data set that we got from DF. And then I'll try to zoom out. So check out where that is located. It's located right at the tip of South Africa. And then remember earlier, the red portion is where there is concentration of AIS data set. So the port Cape Town is most probably located at the area where there is a lot of red color. So try to zoom in close to that red color. Right. When you zoom in close, you'll see the birth, the areas of birth. It means this is where the ships are anchored when they want to do trade and so on. Oh, I answered the second question. So now, our main challenge when doing port indicators is that we need to define the port boundary, and that there isn't really established method yet on defining port boundaries, and then there isn't any available polygons that provide the boundaries for all of the ports of the world. So earlier, the ones that we saw that was presented by Alex and Gabriel, those were polygons that they constructed on their own. So there's no standardized way yet. What we're gonna try to do now is to be able to create a polygon or define that area where there is the area of port of Cape Town port. So we need to be able to put all of those AIS dataset into a polygon. Right. Try to copy the next until the H3 resolution. The next code. So what I did here was to we're now gonna try to put all of the AIS points into H3 indices. So, and then per H3 index, we're gonna count how many points were included in that H3 index. So what I want for you to try out is compute the data frame by trying out different values for H3 resolution. The sample here is H3 resolution 8. So copy also the next part of code until the mapping. What happened here in FREC is that we aggregated the data set into H3 indices and then count how many AIS messages fall into each H3. I also sorted it into the H3 index with the most value. So the first H3 is around 364,000, and then it's comprised of 23%. So 23% of our data is encapsulated by that one H3 index, the first one. Try to visualize the top indices using the next set of codes. Okay, so this is, we're using resolution 8. And then there's also another parameter, cutoff. Can you show the cutoff parameter above? Go a little bit. There's a cutoff parameter. So what I did here was to map out only the top 11 H3 indices, so we don't have to visualize everything. What I'm trying to do is to find the H3 indices that is that encapsulates the port area. So for everyone that's able to follow, you can play around with the resolution and the cutoff. So go ahead and play with the resolution. What if we try? Let's try out a different resolution, maybe I don't know, 9. 9. Let's try out resolution 9, and then let's see what resolution 9 looks like. It's taking a while because remember when we jump from one resolution to another, the number of indices increases by a lot. Try to zoom out. So when we do resolution 9, it seems that it's able to capture very fine areas, but I don't think that the top 11 resolutions is enough. See, it's not covering the whole of the port. Maybe you should try to consider higher number of resolutions. The top 15. Let's try top 15. Still not able to cover. Well, what we want is an H3 index that's able to cover everything, everything in here. When I try this out, I think the best one is what I selected there. It's resolution 8 and the top 11 indices. I think when you use resolution 8, that's able to cover most of the port area, and the top 11 H3 indices is also able to be able to cover them areas. Okay. Try out the original one, resolution 8, and then the top resolution 8, and then the top 11 indices. Okay. And then try to zoom out if really are those hexagons 11. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. See, those are just 10 hexagons. So where is that 11th hexagon? Try to, if you zoom out, you'll find out that one other hexagon. There we go. So remember the faults of AIS data. Sometimes we're receiving location that's not supposed to be in there. So I really don't know why we have location that's within. It's not on the coast area. So what? I don't know that area. So it's probably an error. So okay. So our next step now is to choose the hexagons that cover our port area. When we do the top 11 hexagons with resolution 8, we'll be able to, we will get a good approximation of the port polygon, but we have to make sure that we exclude that one polygon. So I've prepared the code to do that. So go ahead and copy paste the next set of codes. the next set of codes will give us the list of H3 indices, but we'll remove that one weird H3 index, which is out of. So the next is, now that we have a port polygon, we want to create a new data set that only contains the data that is within the port polygons. So to do that, we'll just filter out all of the AIS data, all of the location that is not contained within the H3 indices that we have selected. Let's see now. Can you try to remember earlier we were at 1.5 million rows or 1.5 million observation, and now that we have selected our port polygon, we are at 1.2 million rows. So that's, I don't know, that's 80% of our data. So most of our data really is concentrated right on the port area. So with just a few hexagons, we were able to select the data that is within the port boundary of port 8, right? So far we're good. I hope we're all good. The next part is now calculating the indicators. So we're just gonna do a very basic way of calculating how many vessels have gone through the port, and then we're also gonna calculate how much time they spent in the port. So this is a very simple way to do it. It's not the most correct way of doing it, but we're doing this for the workshop. What I'm doing here, what she's doing here is calculating. So we're aggregating the data set into the first time they arrive into the hexagon, and then the last time or their exit time from the hexagon. Okay, so for example, vessel 9125178, that's a fishing vessel. We have 2 observations that they were in the polygon, and then the time spent in the polygon is from March 28th up to April 12th. Let's try to, the next step is to let's try to visualize how many arrive per day. Okay, so in here I have to ask the participation of everyone. What are your observations on the graph? Feel free to chat it or just open your mic. Anyone has any observation on the graph? Graph shows us the number of ships that arrived in the port polygon per day. What's the trend? Anyone gonna answer? Okay. You're free to answer via the chat. How about you in Kim Choi? Hope I'm pronouncing your name right. What's your observation on the plot? All right, seasonality. There are ups and downs, but is there a specific day? Okay, another one is decreasing. So the reason it's decreasing is because we're counting the ship only once, their first arrival on the port. So it may be that they went into the port within the time period they went into the port, and then went out and then went back in. So the second time that it arrives in the port, we won't be able to count it with our method. So obviously there needs to be an improvement with how we calculate the number of arrivals. How about if there's any impact on, say, because of the rerouting of ships? So the reroute happened around March 23 to March 29. So that's the decision point of the vessels of whether they want to go the Cape of Good Hope route or go to the Suez Canal route. So if the time is from March 23 to March 29, we need to provide a little bit more time for them to arrive at Cape of Good Hope. That's probably at least a week. So from our research, what we noticed was that they arrived by April, start of April until a few weeks from April. But from the plot, we don't see any really spike on the number of arrivals, right? There's no spike. And it may seem that even though there are ships that rerouted to the Cape of Good Hope route, it did not seem to impact significantly the number of arrivals in Port Cape Town. It seems because there's no spike on the number of arrivals. It's also possible that they're arriving, say, a few every day. For example, one or two ships per day, so that it doesn't provide any significant increases on the number of arrivals. There are fewer ships arriving over time. So the reason for that, possible reason is that we're only counting the ship once based on their first arrival. So if they arrive twice, we won't be able to count it big from our code. Okay. All right. So this is an easy way, a simple way of counting the number of ships that arrive per day on the port of Cape Town port. You might get different answers depending on the what we selected for the HQ index, but that's part of the methodology that we're trying to build. All right, let's try to answer the next question. Time in port. All right, so let's now try to compute a distribution of the time in port. We have what can you say about the distribution of the time spent in port? High variation, right? Yes, correct. Is this something that should be expected? Can Gabriel provide any insight on why we're getting this distribution of time in port?
Any other questions? Okay, is there any question from this side of the audience? From people locally, you could follow through, right? Very nice, very nice. Cheryl gave a very nice, comprehensive description of the code. Thank you, Cheryl, for that. Is there any question from the chat group? We're gonna open it. They've been asking quite a lot. They've been participating too, so that's good. All right. All right. So we're gonna, yes, Cheryl, go ahead.
Oh, the final note here is that we're trying to create indicators for port activity, like such as the count of ships arrival and then the time spent. And then we can see from our simple exercise that it's not perfect, it's not the best. It doesn't seem to reflect what's actually happening in the port, especially here in time in port. 40 days, it doesn't seem realistic. So obviously, there needs to be refinement in our methodology, and that's what we need to be careful when we're using AIS data. There has to be some insights from, say, people actually in the field or people that know what's happening at the port, if this is realistic or not. So we should always question and try to understand why we are getting these results. Okay. And thank you Inpyong for running the notebook for us. Thank you so much.
Thank you, Cheryl. Very nice. Very nice. Thank you very much. So from our side, we can say that we can take a 15 minutes break. We're going to come back and we're going to start on the vessel emissions calculations. 3 o'clock, we can be back and start with that. So I will not put it easy on that one, sorry guys. But 111. All right, good. So let's meet up at 3 p.m. 1 second. From those on the chat, I encourage you to, you can start checking out if you don't want to wait a bit that long, you can check out the vessel emissions demo. It should be, well, it is included on the folder you downloaded first. It's a new folder. It has two, well, one file and one additional folder, the file of images and the file of hands-on vessel emissions demo. And then you got a folder of images that's pretty much like a root to have a picture inside the notebook. So we will go through that as well. But you can start and you can start checking out the code and probably solving it, because we have made some, it has some errors on purpose so people could troubleshoot. So if you like to go through that from now, that's also welcome. So see you in 15 minutes. Vessel emissions from your Jupyter notebook. All right, before we get into the code itself, I am going to share a presentation that gives some introduction on vessel emissions. This introduction becomes relevant when you want to think on the assumptions that are taken to calculate emissions from ships. All right, on the chat, can you please confirm that you can see the slides and that you could hear me? All right, yes, that's a yes for an answer. Thank you. Thank you for the feedback. All right, so let's talk about emissions calculations and how to get them from AIS information. I have to stress that we're going to follow a method called the bottom-up method. The bottom-up method is very well documented from several literature papers and also from official reports from international organizations such as IMO. First of all, where does it came from? So right now we are under the umbrella of the fourth IMO greenhouse gas study. That's a report created by the IMO where they gather global information on emissions generations from vessels. The first version, as you can observe on the picture, was delivered in the year 2000. The second version in 2009. And if you recall from an explanation of AIS, AIS has gotten, we have more frequency on AIS information from the year 2014 and on. And with that, the better follow-up of emissions calculations with AIS information. Also, as you can notice, the reports are not that frequent as it takes some time to have a full report done. So lastly, from the greenhouse gas study number 2 up to greenhouse gas study number 4, there's a 5 years between every report. So that becomes relevant at the time that countries and port authorities would like to have more close statistics to what they're living in a close to real time or in a higher frequency compared to these reports. So what happened in this fourth IMO greenhouse study compared to the previous reports? First of all, they included emissions of carbon intensity. That's a concept that is very much aligned to new regulation introduced by IMO. We should enter into force in November 2022, this year. So pretty much they try to calculate something that is more related to what the future calculations of carbon intensity will be, namely the annual efficiency ratio, that stands AER. So they calculated retroactively on the year 2008 and compare levels from there on. Also, they have included the emissions inventory for worldwide shipping activities on gases. We have to remember that from the Paris Agreement, surprisingly or notably, the IMO and the ICAO, standing for Aviation Organization, they were left out of the Paris Agreement in the sense that as they were regulated by international organization, it was thought at the time that it would be easier for them to have their organizations establishing the policies for gas reduction and their impact on climate change. So far, there has been some discussion on how successful this organization has been. And at least for IMO, they decided to go closer to the United Nations framework Convention for Climate Change that was brought up from the Paris Agreement. And they start monitoring the same gases that they plan to monitor from that convention, namely the carbon dioxide, methane, black carbon, nitrogen dioxide, hydrofluorocarbonates, perfluorocarbonates, and sulfur. Well, I forget the last letter on the last one. But the thing is that everything has been standardized, so you could follow through on both sections, right? Of course, IMO has been also collecting gas emissions on some gases that are more relevant to shipping activities than any other activity, namely nitrous oxides that pretty much comes on combustions and the air levels of the combustions, non-methane volatile organic compounds, particle matters, and sulfur oxides. And it's peculiar because sulfur oxide is pretty much eradicated on almost every transport unit, except for shipping, where vessels still use heavy fuel oils with some sulfur content, even though now there's stringent regulations and a global cap for vessels to ensure that they have under certain threshold of sulfur within their emissions, known as the Global Cap 2020. So to summarize the main contributions of this study, of course, it benefits of a large and significantly larger AIS data pool when you compare it to the previous study. So you could assume that the levels of accuracy go better. The emissions inventory is now distinguished between domestic and international emissions. And of course, new literature came after 2008, 2014, when the Greenhouse Gas Study 3 was delivered. So we have more accurate methods for calculating emissions from AIS information. This is an important section. As is explained in brief, the outcome of the study. First of all, there was an increase from 2012 to 2018 on the emissions caused by ships, which, as I explained before, gives some ideas to think about. If shipping was considered a country, it would rank 6 because they emit 3% of that global. Try to think about it, that global emissions. So that includes cities, transport, trucks, everything. So shipping by itself emits 3% of all of that, almost 3%. So overall shipping emissions increase in absolute values from 701 million to 740 million. There's an increase in there. But surprisingly, this carbon intensity indicator that explains how efficient vessels are operated decreased by 21% compared to 2008 levels at 2015. And check out the graph at the right. You find a decrease, but then it's stabilized and remains steady, signaling some efforts of shipping to try to catch freights faster and increase their speed once again. So there's an important matter of commercial operation that also have impact on emissions given by vessels, because let's say when the market is hot, vessels will try to go as fast as possible to get as much cargo and more visit as possible, causing emissions or higher emissions at the same time. So all of these aspects needs to be considered when or has been studied in the sense of policy making when trying to deal with emissions, that everything needs to combine. A vessel cannot only be emission efficient, but also needs to be commercially viable. As more transport produces stable freight rates, that produces stable speeds, so on and so forth. So to explain a bit and make a description of the methods, the first one I'm going to explain is a top-down method. That was pretty much used on the second report in 2009. The main reason, of course, being there was very few AIS information at the time, so they were finding a way to calculate emissions by collecting fuel sales data, by asking the suppliers of fuel how much have they sold, and then transforming that to emissions. So you could think that that might overshoot or undershoot some of your calculations, because it's barely impossible to get information of every single supplier in the world, right? So this is an important thing in terms of information accuracy. Then came up the bottom-up method. That's a method that was brought in the greenhouse gas tree. Of course, before that was already studied in literature and was like published and peer review, and you had several publications feeding this report method. And it's pretty much based on ship type, saying that you have some assumptions that you take and are also very well explained on the report methods, where you can use that information to derive how the emissions level of a vessel based on their operational phase, namely if the vessel is alongside a terminal or anchor or on their way, etc. And of course, the vessel specifications, meaning that a tanker vessel will not emit the same as a container vessels that have a different type of engines that normally goes on a different speed, etc. In this greenhouse gas 4 study, they included the voyage-based bottom-up, which in summary is pretty much calculating emissions from port A to port B, with some lakes in the anchoring and the emissions in the anchoring port. And the motivation behind that was pretty much related to the incoming regulation that is getting into force this year. So the results that they got there could be compared to what is going to happen later on with the new regulation. And I will just make a brief introduction of what the regulation is later on. So this is an important case. This is a case of the Panama emissions calculations. This is getting prepared so it could be read on almost real time. So you can make policy shifts based on that. Notably, so far, if you take a look at the image, you can see some spike in some areas. This could be identified as vessels anchoring significantly amount of time. So that connects or derives to the fact that if you have better port assignments, meaning lower waiting times, your emissions are likely to come down more certainly, right? So there's this connection about port efficiency and waiting times vis-a-vis emissions reduction. So let's talk a bit about the work on carbon intensity indicators and how it was motivating these voyage-based bottom-up methods. So the carbon intensity indicator is pretty much grams of CO2 divided by cargo carrying capacity times nautical miles. You can see the formulas of 2 options for carbon intensity at the bottom part. So pretty much like summarizing all the CO2 generated by a ship on a voyage, divided by the static deadweight tonnage, that's the capacity of the cargo weight of the vessel, multiplied by the distance. So it pretty much favors those vessels that, one, emit less, at the same time that that have a better utilization of those emissions on shorter voyages and thus better in having operational efficiency. This value is becoming significantly important on shipping because this value has, by regulation, needs to be reported annually from the year on. And that report gives you a standard or a ranking. You're A if you're a very efficient vessel, and E if you're a not so efficient vessel. The implication of this is like if you are E for a year, then you are obliged to present a plan to become better than E, to improve from E. That also applies if your vessel gets 3 straight years of being a D vessel. That also extends to the commercial part, because more and more charterers, those that rent a vessel for carrying cargo, are more concerned on their own impact, on their own emissions. Hence, they will try, or at least that's what is foreseen, they will try more and more to hire vessels with an A ranking to transport their cargoes. So this is mandatory from November 2022. The first certificate should be ready in January 2023 for all vessels, and then every year you have to update that value. And it applies for both vessels that are measured in cargo weights, such as tankers and bulk carriers, and vessels that are measuring gross tonnage, that is the volume a vessel can carry, and that's for container vessel, cruise ships, and roll-on, roll-off, and roll-up passengers. Okay, with this slide, we are gonna introduce our hands-on event for emissions calculation. The roadmap for the bottom-up method uses the following steps. First of all, from the data, you need to identify what the vessel is doing operationally. It's either anchoring, meaning waiting with their anchors down, waiting for entry into the port. Is it on their way? That means like they are just sailing as regular, just passing by, close to your port, but going somewhere else, or coming to your port. Or if it is the vessel is alongside the terminal at berth. Of course, the operational phase dictates what level of emissions your vessel is gonna drive, right? The next step is to estimate instantaneous power demand of the main engine, the auxiliary engines that are used for generating electricity on board the vessel. The main engine is pretty much for propelling the vessel, and then auxiliary boilers that are used to heat services, such as heating the water on the vessel and perhaps heating cargo if you have an oil tanker vessel. The next step after that is allocating the fuel use. You could be changing fuel based on the area that you are. There are very stringent regulations for going to the US, for instance, where you're only allowed to use certain levels of sulfur when you're getting in, and you cannot surpass that threshold. That's very well respected because the fines are hefty. So this is an assumption that everybody could rely on. Then you estimate the fuel consumption with all the previous information, and from the fuel consumption, then you derive the emissions. So there are a couple of steps in here. I would say that is sometimes quite challenging because you have a lot of dimensions to get into account to have the proper emissions function running at. So without further ado, I will invite you all to go on the hands-on session. You do that by entering in the same Jupyter notebook account you installed before. But in this case, you are gonna open a file called hands-on vessel emissions demo. It's inside a folder called vessels emissions demo. It's the same case. You will open a kernel, the same kernel you used before. There's a Sedona and finishes with new bucket. And then we will be ready to go in brief. A lot. So I got the answers. Okay. So once you're ready, please let me know. From the chat, I will appreciate if you can update that you could follow that you could open the notebook. Please note that the notebook has some errors on purpose, so we can solve it all together. Okay? Yes. The presentation is only on the folder. Yes. Okay. Abdullah says that it's in. Thank you. Okay, let me open the file myself. I've been a bit slow today with this. Yeah, yes, just give me a second to open my API. I got it on. I will just open my own session. Where's my USB? No, have you seen a USB drive around? Like a USB drive is like a gray one. Yes, no. Perhaps I put it on my back. There it is. Okay, my turn to log in. So while everybody logs in once again, I'm gonna open my my Jupyter notebook and share screen once again. Okay. Thank you, sir. Wonderful. Thanks. Right, I'm opening now my session. Okay, I think everybody will be able to see in 1 second. All right. Can people online see that? If you could follow if you can see the my Jupyter notebook.
I don't have my card.
I got your code. So very close. Okay, sorry, my pleasure. Okay, thank you from the chat. Yes, you can follow my screen. Okay, so let's please go and run this through. Try to run it until you stop, because there will be a moment that the code will stop because there's an error, okay? Let me know when you find the first error. Those are starting to learn coding, don't worry. We will pass through and I will let you know what the errors are, and I will also share with you at the end of this session a link so you can download the solution proposal for the whole code. Meaning that with that code, you can just run it through and it will calculate your emissions. Yes, yes, of course. But they have downloaded already. Okay, yeah, yeah. So from the chat, please let me know when you find the first error and tell me what the error is. So you might recognize that you have an error because when you try to run a box, it will not show you a number, but it will show you something like this cannot go through because there's an error on X. Okay, this seems to be right. I give you a hint, it's somewhere around here. Ah. So from the chat, yes, somebody just answer. Yes, it's Mark asking. Yeah. How do you fix that error? Also, please use the chat to let me know. All right, Prakash, you're very engaged. Thank you. So it's a GPD package where, just for you to know, all the packages or all the modules are in the top part. So there's a package that should be called GPD, right? So perhaps the error is somewhere here. Yes, we can see from GeoPandas, that is the one that we're trying to run, that I, on purpose, just missed a letter. So these pretty much are the kind of troubleshoots that you're going to find when you start coding from scratch, right? What you will do is pretty much like, there you go, Prakash. Thank you. Wonderful. Go to the first block, and whatever it's, when it says import GeoPandas as GPD, as GP, include a GPD, right? Then you will run it again. Run the box one again. Okay, it should have read that one. And we are free to go once again to that section that was having the error and run it again. And then it went through. So that was an error, yes. Okay, so there's a question related to this one. If somebody could help me out in here. You have printed in the previous box, you have printed already your types, right? That means the variables that you have on that database. Can someone tell me what is the key ID, the ID that allows us to identify unique vessels? I will give you a hint. There are two. You can give me any of them. Prakash, MMSI. Wow, Prakash is on a row. Thank you, Prakash. MMSI is a good key ID. That means that there's another one, and I will give you a hint so we can go through. Is a perhaps a very important one. There you go, IMO. Very good. Yes, Prakash, you get a chocolate, but you have to come up to Dubai and pick it up, okay? All right, let's move forward. So we can go on the transform GeoPandas to Sedona. And we do this because for handling queries, spatial joins on big data, we cannot do it itself by GeoPandas. We have to go to Sedona. That is a package that allows to make special partitioning, spatial like a spatial, like things with geopositions. So you need to do that. Just go through it and just run it. I will tell you there's no error there. It will just take some seconds to go through because then we're transforming our setup in here, right? Okay, now we go to the part that we are gonna plot whatever polygon we are gonna use, right? Just go over and run that one. Okay, this polygon has a question. What ports can you see in the polygon? Abdullah, perhaps you have a better knowledge on this one. What do you say? What geographical areas does it cover? Give me one or two. Of course. And you got Alcharja también. Yes. Actually, we're inside that polygon too, right now. So if there was a ship here, you get that one detected too, right? I don't know what they are. they were just close, sorry. So you can recognize that you got the Gulf entrance in here, right? Dubai and Abu Dhabi, yeah. Al-Sharjah perhaps. Yeah. You got chocolates? Okay. So this is an open question. This is an open question. What kind of polygons would you use? And this is open to everybody. You can tell me something about the Philippines, for instance, with some of our people at the Philippines. Where would you put a polygon? Remember that the polygons are those areas where we're interested in having our AIS information derived from and where we want to make our studies or perhaps local apps. So just write in the chat, where do you think that you could use polygons for your own work? Somebody from here? What about Indonesia? Do we have some Indonesian people at the chat as well? Or people from Panama, we got a couple too. So what areas do you recognize? Kisat? Yes, thank you. Becomes an important place for you. Very good. Okay, who do we have on the meeting still? Jebel Ali, of course, an important port, right? You can derive important information from there. Thank you, Prakash. Right, very good. That was an open question. Was you to take into account that perhaps the default polygons are not good enough for you, so you can create very detailed ones with the shape of the ports and you can run around. The way I do it, I go to Google Earth. There's a function in Google Earth where you can create polygons, one point at a time. You can make it as detailed as you want. The polygon is going to be the area that we're going to investigate. So everything that goes inside the polygon is going to be detected by this big data query. And that makes it easier for us to handle it afterwards because it makes that data size smaller. Okay? Okay, you can make it as small as possible in Google Earth, and then you can export it as a KML file. And then there are several online tools that converts KML file to a file format called GeoJSON. So it's geo from geographic and JSON. And that is read by GeoPandas with no problem. Okay? Okay, let's run the next box. What happens when we run the next box? It should take a couple of seconds. I promise you that there's no error in this one. And I did it on purpose because it's a bit complicated to handle spatial data itself, even more complicated to do it on big data, right? So I'm going to briefly explain what's happening here. First of all, I got some code running that recognizes every longitude and latitude and convert it to a geographical format called points. So it has a point that has a latitude and longitude, and it creates for all the records we have on the database. Then we pass that to something called RDD. So it could be merged with the polygons we created before and that are also RDDs inside Sedona. Then we do something called special partitioning. That is pretty much like ketchup and salt. The final result in here is like we make a join. A join is like it detects the polygon and it takes all of those points one by one and make a special query that is asking this merge, give me or return to me only those vessels that are inside my polygons, or only those positions inside the polygons of interest. Can somebody tell me how many points we got after we query the polygons? Or we make the spatial join? So it should take some seconds to transfer. Excellent, we got 380,000. And if you recall how many we had before, we got about 1.2 million, right? So you got a decrease there of almost 70% just in one very fast query for spatial analysis, right? Geospatial analysis. All right. So who can tell me what kind of join with this? This is a picture. Try to imagine that the left picture is the polygon and the right picture is the points. What kind of merge we did in here? I will give you a hint. since we already had 1 million on one, and then it reduces to 300,000, that tells you that this is not a left join, because the left join will keep all the records of the left-hand side database, and will maintain it with the right side. Prakash, you're completely right. This is an inner join. What happened here? The query would only return those values that are within the match. Everything that goes outside on both sections will just be deleted. You will not see them again. Okay? If you want to do any other type of join, of course, you can select it also through the options on the previous box. Okay, we already answered this one. Why are there less points after the special join? You already helped me out on this one because we did an inner join merge. Okay, let's go and run the next box. Let's see what happens. Okay, we got an error there. All right. Let's troubleshoot the error. I will show you the error on the screen. Okay, it seems that there's an error with the MMSI. Remember, MMSI is important, right? So what's happening in here, is this line over here. They are unable to make the merge on MMSI. We're using the MMSI to make the merge with vessel specifications. I will just give a bit of context of this section, right? So we got a filter in here that says that every IMO number that is null, in that case, remove those from the database and put it on a single database and separate those. But in that case, you will use the MMSI as your indicator, because since you have no IMO, then you need something to recognize your vessel. Then your MMSI is passed through, a new column is created, and we transform this column so we can have geometries. So at the end, we have MMSI indexes and IMO indexes. In the IMO indexes, we're using those that already has the IMO number, so you don't need to do anything with that. What we're doing is trying not to lose data from this filter, and we're just separating it by a logical test. Then we read the IHS. You remember I explained before, we have a database for vessel specifications. That is read in here. This is the syntax, and this is the index or the URL for getting that information. That information I mentioned before fixes pretty well in your local computer. However, for illustration purposes, we're going to keep using it on the Spark session. Okay, can somebody tell me what the error is? And this is a bit tricky. I will just give you 2 minutes of doing that, and then I will jump on the solution. So we got an error on the merge. That's pretty much line 16. It says that, okay, I want to merge my MMSI indicator with my specifications, but we're going to use the MMSI over there. Okay, great, Prakash. The MMSI column might not be available. You're close. So that means that if you take like 5 minutes more, you will troubleshoot that. And I will give you the answer. It's pretty much the case that we introduce a wrong, or we just introduce a wrong name on this one. I will repeat that. This column is not called Maritime Mobile Service Identity MMSI. This column is called Maritime Mobile Service Identity. And you can check out that with having a search on the columns names and then verifying what is exactly the name of the column. Because if you don't put it exactly, including cap letters and such, then it will not go through. That was the error over there. It's running again. I hope that was the error. Okay, there's another error. Let me see on it. Just 1 moment. Okay, seems that it was not, so perhaps I have to shit a bit on checking out my solution proposal because I don't remember. Huh? Yes. It's MMSI number. Yeah, I should have opened my battery over there. Okay, so we got some help. That's yeah. Ah, it was okay. Yes, I got help from a friend here. MMMSI and then number. All right, like that. That is supposed to be. Yeah, it seems that it went through. That was the one. Yes. Thank you, Marky. So I was right on the error, though. Yeah, nice, Ricky. That I don't. Yeah, I will open the solution proposal. Perhaps that help out. Yeah, I got it there. All right. So close your eyes while I scroll through this. Where are we? Here we are. Yes. Okay. Oh, I close this. Next box. There's a question. Okay, check out the first line of the previous block. That means on the previous one. So why haven't we filtered? Because those that knows Python and know Spark could tell me, like, why are you filtering through a string? Like, why you're telling the system to filter through a string? Well, there's a function called isNo that does the same thing. So why does anybody think that I had to do it through a string? I will give you a hint. It has to do with the D types, the type of the variable. Okay, I will give 30 seconds for that. Check out the first line. I will highlight it. We got a filter called result. So we got our results from our Spark environment. And then we filter the columns that has IMO that are empty. I ask the system to collect those. And I rename those filters as MMSI, meaning that I don't have an IMO number. So it is impossible for me to recognize that information in that vessel. So then I will use the MMSI number. That is also a secondary way of doing this. And I make a filter telling, check out every column that within the column called IMO. Whenever you find a null value, bring it on the MMSA database. So why do you think I didn't do something like, which is significantly faster for querying? Yeah, I know that's a difficult one. I have to be honest. Right, what's happening here is like, if you search or you check out the D types, that means that how the variables are constructed. What we get from the global platforms are IMO numbers on strings. So first, it will be very heavy to transform it back to a null value that is a value as a float. And secondly, it's unnecessary because you can just go through it and filter it as a string. So this column was already declared a string. So in order for us not to go deeper and make some expensive calculation, we just filter it as a string, all right? So that's the answer on that one. And the second part of the question is, what is needed to do isNo? That is a very efficient way of filtering. Well, you need to transform this column into a float type. That means a decimal column, meaning that it will put decimals on the values that has, on the rows that has values, and it will put null on the columns that does not have values, but it will declare them as float. This is one of the most difficult questions on this one, I have to be honest. But it's an important question because lots of time you realize that you start troubleshooting around a problem because the types of the problems were wrongly defined. And you figure it out like after a lot of trial and error and a lot of search, right? So we already filtered our database. We're gonna get to the funnier part, and that's transforming our database, our Spark data frame to a pandas data frame that is pretty much usual. and vessels can recognize what they can do on their data frames, right? So on the next step, we're gonna use only one vessel that has an IMO number 9802308, which I have already noticed on my friend's computer. He already Googled it, and he found it on Google. You find the picture. It's a bulk carrier with probably handy size, and you recognize it's a handy size because it has cranes on deck. So we're gonna filter only one vessel, and here comes an important change pattern. I will suggest that as we have this big machinery, cluster machinery in the global platform, then try to query through the global platform as much as possible as soon as you can reduce it the most as you can. So this is coming back to our divide and conquer strategy that we did at the very beginning. Within Spark, you can do group buys by a protocol called partition by. In that sense, you can partition by the IMO number and then separate the vessels and process vessel by vessel on different settings. If you are familiar with pandas, that is pretty much a group by, but called differently, okay? Let's forget about that, and we can talk about that in another moment. There's significantly more complications behind that. We're just gonna transform the filtering with this single vessel to a pandas data frame that could be handled easily by many people that learns to do data science as a regular basis. So let's try to run this box. What happens? Oh, we got an error right away. Seems that the error is on the second line. I will give 30 seconds for somebody to let me know what's going on here. Remember, we should transform this information from Spark to pandas. So there's something missing in there. The pandas merge cannot go through because, I will give you the hint. I'm telling to merge a Spark data frame to a pandas data frame, and it doesn't work. So you have to do something before going there. You cannot merge a Spark data frame and a pandas data frame. They both need to be the same. So what will be the case in here? How do we solve the problem? Probably we got answers. Abdullah, data type mismatch. I would check that as well. That might be an option, yes. Abel Gonzalez, wonderful, wonderful. That's the solution. On the first line, you have to introduce, follow me through, to pandas the way that Abel proposed. And that is like all together with the P as a capital letter and then opening, closing parentheses on the first line. Okay, let's run that. Seems that it worked. And we got a beautiful picture at the very end. It's a frequency histogram. So what information does the histogram tell us? Let's see where it was constructed, pretty much in this line. So we got from the sample, we got one row called DT position UTC. That stands for date time of the position. So every row has a different timestamp. And we are deducting it from the previous row. So we want to know the frequency between row by row. This is an important test that I like to do in all, and I like to present in all the papers. And if I had to review a paper on AIS, that's the one that I'm going to aim for the first, because I want to know the quality of your raw information. And it goes connected to the fact that if you have garbage in on the model, you will have garbage out. So I need to get sure that your data, raw data, is robust, okay? So pretty much we calculate hourly data from this sample over here. So I'm telling the pandas, I'm telling pandas to create a new column called frequency. And that frequency is gonna be calculated as a difference between the daytime stamps of one position and the previous, and I just include this to divide it by, so I can have a decimal of hours. So that means that if I have 1.0, that means that the frequency between my position and the previous one is 1 hour. If I have 0.5, that means that that's 30 minutes, half an hour between position 1 and the previous, okay? So this calculates the same for every single row. So we have a plot afterwards of a histogram. And that tells us that most of our positions, or at least we can fairly say that our median is within 0.2 and 0.3. Let's put 0.2 to be safe. And that's like our positions are coming every 12 minutes in our raw data. For practical purposes, 12 minutes is a good enough frequency. Fortunately, because vessels are slow modes of transport, and you will expect vessels not to move much, even though they're sailing in 12 minutes. And if a position are missing, it's very simple to interpolate in between by doing the triangulation via a regular Pythagoras theorem. So you got longitude, latitude, you got an hypotenuse between the both, and you can make a triangle, all that on a code. And that tells you where the position should have been in between when you have a time difference, okay? So I will not get deeper on that because that's like a whole different course, how to get better or interpolate better data. You can use from interpolation methods, such as regular linear interpolation, or you can use Kalman filters as I do, etc., etc. So I got an open question. I want an answer on this one. It is an important question. So do you consider the frequency between positions important for calculating emissions? So it's a yes or no question. What do you think? It is important, Abdullah. Yes. Why would you think it's important? So I will put you a hypothetical example. What happens if we have positions every 4 days, for instance? Instead of every 10 minutes, every 4 days. Yes. Okay, wonderful, wonderful answer, Abdullah. Yes. Abdullah mentioned that we might miss some important information in between, right? A lot of fuel could have been used, and there were some emissions that could have been produced. Most probably the vessel change operational phase. Remember, operational phase was on the important steps for calculating emissions. Or the most popular one, if you don't have a good frequency, you have vessels crossing land. Unless you're a Viking or you're on a Viking ship, that they use when they couldn't have an access, they just push it through locks and they pass it through areas that they could not sail. It's very unlikely that you have a vessel crossing land. All right? So it is important to have high frequency to get this type of calculations. And I got another question. How would you interpolate timestamps? I already gave the answer to that one. You can use linear interpolation or Kalman filter. I will not get deeper on that. But these are some of the options. Prakash mentioned that we might miss the route. That's also an important aspect. So 4 days away on a sailing ship, I will put an example, is like having a vessel in Colombia that is like in the close to the equator. And on the next timestamp, there probably will be around Cuba already. So what happened in between? There's a lot of water in between. So that's an important gap. Okay, so we get to the next step, and it's, remember, we got the steps for calculating emissions. Starts with following the greenhouse gas for report. I gave a link already. You can follow it through at the very beginning of the notebook. Here's the link for the report. You can download it for free. It's on the PDF. I'm sorry about the document, but it's not my fault that it's 600 pages. But the good thing of 600 pages is that everything is well documented, and you can just jump some sections that you don't like to see. Right? So we're going to start calculating emissions now. So we have our frequency data, our source data is really good. We just go through this one. I think this is going to run good. So here I imported the table that I have created for the purposes of this session. And pretty much it reads a JSON file on my website and brings out the table so we can use it later on. Right? So these tables, and you will see a lot of these tables being loaded from my website, are a transcription of tables you can find on the GH4 report. So you can pass it by hand and you can start doing the tables so they can make it easier for computation, right? Okay, we just read an auxiliary engine and auxiliary boiler table so we can calculate later on our auxiliary engines, emissions. Okay, let's go to the next section. Here I pretty much start constructing the important information for calculating emissions. I will just pass through them very quickly. We have the auxiliary engine power constructed at the first line. A little bit before, we have the auxiliary boilers power constructed for that. And it uses information from the previous merge we have. The power is kilowatt of the specific vessel. And they have some logical tests so they can allocate your vessel on some bins, let's call it like that. Then we created, then we merged it with the auxiliary engine, auxiliary boiler table that we just uploaded before, or we loaded before, and create some other variables. So there, to be honest, there are quite some steps to follow on this one. But once you get it automated, it's just a matter of adapting it. So pretty much what I do is like do this for one vessel and then escalate it on big data. Okay. So this seems to be running properly. I encourage you, if you want to follow step by step or you want to ask questions, read out the description at the very top of every box. And if you still have questions, you can always contact me and I will be happy to further describe that. Okay, we read another table. Aha, we get to another problem. Okay, there's an unsupported operand type. So we are making a division. That means that we're making a division between a float, that's a type of data, that means a decimal, and a string. What is a string? Who knows what is a string? What's the best translation for a string? Yes? The best summary you can have on that is text. So you're trying to divide something that says that you could write 3 as a text, right? So you're dividing that text 3 by 1, and it's an error because you need to have that defined as a number. And it seems that our error is going to be, let us follow, where was it coming from? Line number 5. Okay, line number 5 is somewhere, sorry. You're welcome to troubleshoot as well with me. Okay, so this is line number 5. Seems that the problem is here, and the only division that we have, well, we have 2 divisions, right? So we have one division of draft with lowercase and draft with uppercase. And I will tell you what happened here. That draft with uppercase came from the vessel specifications, and that stands for summer draft. That's the maximum capacity a vessel has when it's fully loaded. So you pretty much are building a ratio here to recognize how much of the vessel is loaded. So that means if you're fully loaded, your actual draft, the one that the vessel reported, when you divide it by the summer draft, it should be 1. And if your vessel is in ballast, that means with no cargo, it is not going to be 0, but it's going to be significantly low, something around 0.3 or 0.4. The vessel never will have a draft of 0 because they are, when you have no cargo, they're going to have water ballast inside for stability reasons. So you can recognize very easily when the vessel is loaded or not by making this ratio comparison. So I think that the problem was there. Okay, how can we solve that problem? Let us troubleshoot that very simply. We're going to observe within our data types. We're going to just type this one and see what's going on with our data. Okay, I want you to show me everything. Over here. Okay. It doesn't give me that. Ah, yeah, I know what. Okay, and then I will put just simple columns. Okay, I'm gonna search really quickly where the error is. I didn't put it one together with other. I need to make a merge over there and or make a new list. That's fine. Let's search for draft. It should be somewhere around here. I will put directly draft, and I want to check that the types of draft. I'm being a bit sloppy over here. Okay, it says that it's an object. That means that it is a string. What about the other big draft? Ah, there's our error. The error is pretty much that our lowercase draft, the draft that came from the AIS records, is a string. So that's why we cannot make a division. So that means that before it goes into that operation, we need to transform that single column to floats. And we're gonna do that, and I've been sloppy here, but I will just take it from my battery. There you go, I make it like this. This is the one. Okay, so pretty much it's like, okay, get me the same column, but now transform everything that is a number, transform it to a number. So you will find some strings over there, but overpass that and get me numbers on that. So we put this simple record, and I will just keep it like this for 15 or a bit more, 30 seconds, so people could write it down. So those that are following us, please type in your notebook this record over here, pretty much like sample equals sample that assign, and then open parentheses, draft equals pandas PD dot to underscore numeric, and then introduce sample draft and close parentheses. Perhaps I can write it down on the chat to make it easier for some of you that are online. Yes. There we go. So I put it on the chat for those that are following online. Just copy that one and put it just below sample equals PD merge. Yes, let's run it. Okay, there's another error now. You got the same error? Okay, there's an attribute. There's no attribute called weather. Yes, I remember I put 2 on this one. You found it? You got the same problem. Okay, that might be. Yeah, but that's fine. We get it through. Don't worry. It's not from here. That pretty much is because we need to go all the way back to do something and like read. Ah, I know. Okay, it went through. Yeah. There's no error on that one. Try to run it again. Read this one. So for those, you can read the previous section. The previous box, the one that says URL, etc., etc. We read the. It shouldn't be a problem there. There you go. Okay, so the troubleshoot on that one was because perhaps the sample gets all messed when we like didn't have the error. So you have to load again the table from weather on the previous box, and then you can jump directly on the next one, and it should go. Okay, no, it's an error again. Just run it several times. It will get through eventually. All right. Yeah, it went through. Okay. Remember that I'm sharing with you the fully functional solution proposal later on. Okay, let's go on the next one. Once again, another table, and this table is for calculating something called a main engine specific full consumption function. So it pretty much merges the database with another separator where it detects if a vessel is older than 1983, it have a different consumption function. If it is between 1984 and 2000, a different one, so on and so forth. It should run. The next one is for estimating the main engine fuel consumption. So we do a merge. So this table is the one that we just loaded. And then we make some logical tests so we can have the date of build. So from any of this data, or at least from IHS data, we have no, we cannot identify when the vessel, the year of the vessel, unless you transform it. We have a column called date of build. So that is month, that's a year, month, day, in a sequence of numbers, uses as strings, or as strings, yes. So what we need to do is like, try to chunk that or cut it in a way that the standards turns you back the year of build, and then you transform it to a string, to an integer. That's another data type, which then you can use to filter between ranges of numbers. Okay, so that makes it easier for filtering. That's the bottom line on it, but I do know that there's some complications on that, and perhaps you may have to follow. Remember that every function on every table or any box in here has a proper reference with the page number and perhaps the table that we are using from that greenhouse gas 4 report. So if you don't understand the code directly, you can go to the greenhouse gas report and understand the function over there. So everything here has been transformed as they said. Oh, this is a very technical one, but I will just throw it anyhow. Perhaps I get some surprises in the audience. So what gas emission? So we had several gases. We have carbon dioxide. We have, I will put 3 examples. What gas emission control is based on vessel year of build at the MARPOL. The MARPOL is the International Convention for the Prevention of Pollution at Sea. Annex 6. Annex 6 stands for air pollution, the section that regulates air pollution. So what gas emission control is based on the vessel year of build? 3 options I will give. CO2, methane, or NOx. NOx standing for nitrogen oxide. Yes. Abdullah mentioned methane. No. Methane is actually it's not very well regulated. I would not say well, or well is a bad word for this one. It's not as regulated as some other gases in the convention. So you can disregard methane. You got now 2 options, CO2 and NOx. Prakash says carbon. Surprisingly, there's no regulation for carbon because it is very difficult to regulate carbon. So that gives us that last answer. NOx. NOx can be regulated by engine manufacturing, meaning that if you have a vessel of certain age, you are required to comply something called tiers on your engines. So that means that you could even have new engines if your vessel is fresh new from the shipyard, or you can retrofit if that accommodates to you. Older vessel, of course, it will not be commercially viable, so they have like more flexible restriction for NOx. So NOx is the right answer for this one. All right, so we're gonna read a new table. So that's for calculating auxiliary boilers, specific fuel consumption. Auxiliary engines and auxiliary boilers does not have a regulated, or at least doesn't have a very specific function for calculating this. So by merging the information from the table is good enough to calculate emissions from auxiliary engines and auxiliary boilers. I will recall that auxiliary engines is pretty much used for electricity generation on the vessel and electricity demands on the equipment, including the propulsion of the vessel itself, but that propulsion is mostly handled on the combustions of the main engine, right? So you might identify that auxiliary engines and auxiliary boilers, bigger triggers, or where they have more impacts is when the vessel is waiting. When the vessel is waiting, the vessel is not moving. So that means that your main engine should be shut down. And the only emissions that you're generating are from these diesel engines you have inside the vessel for generating electricity. So, but remember, a vessel is a big structure that demands a lot of energy. Hence, these engines also have some important effects on emissions generation. Meaning that longer waiting times on these big vessels also have an impact on local environmental, earth health, and global environment emissions. Okay, let's jump to the next one. Okay, we got an error. Fortunately, I remember this one. So I will give you a hint. It's getting late already. I'm getting a hint. The error is on this line, the line that I'm highlighting here. And the error is that I actually, on purpose, name a column wrong. What column is it? Okay, somebody from the chat. This is pre-open. Remember, guys, it sounds frightening sometimes, but I'm pretty sure if you're doing the whole code, these kind of things will show over and over and over again. And it seems silly, but after you're like tired doing some coding, this becomes more and more frequent. You want it? Okay, I will just give the answer. The answer is that it's not day of build. The answer is that it was date of build. Okay, we still got the problem. Let's run it again. What's it? Year of build. Yeah. You're right. So yes. I am tired already. That's true as well. So year of build. Yeah, I got corrected by my colleague, and he already recognized I'm also tired. So yes, year of build was a proper column. You got the chocolate already. Yes. You're ready. You can charge your chocolate at the end. It's like and people that is online as well. If you have some answers asked correctly, I will send you an online coupon, and you can retrieve it whenever we see us again. We can send the chocolate in the post, but they have to pay taxes, though. Perhaps. I don't know. Depends on the country. Eh? All right. The next box should run properly. Well, this is a construction of having a main engine consumption. So we prepare all the information that we've been preparing before, and we put it together. There's a function for that, and then bloof, you got main engine consumption, fuel consumption. Remember that consumption goes row by row, timestamp by timestamp, meaning that you can disaggregate that by time period afterwards. We read the table, another table. Okay, this table is for emissions factor, and this is an important value. We'll just make a quick stop in here. The emission factor is an assumption made from several, I would put it simple, linear regression that people ran and identify some common patterns between how much you use of fuel and how much it does emit afterwards. So it's pretty much a transformation factor where you multiply your fuel oil grams. In this factor, which unit is grams of CO2 per kilowatt hour. And then you get at the end your transformation, right? Once again, you can check out all the information from the Greenhouse 4 report. Rerun the next one. It should create Okay, information on CO2 grams already. And the main information that it got as an input is it uses the main engine consumption that we calculated before and transform it by multiplying the emissions factors, CO2 in this case. Another table, I'm sorry. So this is full of tables, but I did this way to pretty much get whatever was on a book or PDF in something that the code could handle properly, right? The whole day job, boring job. Okay, we got CO4, and now we're gonna estimate methane emissions. Another error. I do remember when I was doing this, like, okay, it's not many errors, and it was fine. Now I'm paying that decisions. Okay, we have an error on the second line and says that we have ME type is not unique. So to be honest, guys, I'm just gonna jump on the cheating on this on the solution proposal for its ME type. So we went through this already. Yeah, I think I remember what was it. Okay. Well, yeah, the same problem. Okay, this shouldn't be the case. ME type is not unique, and the error is on the second column, so that means here. Why? So I'm replacing columns. Oh no, the error is there. It's on the merge. Oh, this is funny. Just gonna scroll through that. Let me check. We should have reduced columns now, so it will be. We have something called MEE types. Yeah, just bear with me, guys. I know you're all tired and it's hitting me as well, but I promise I will get through this soon. I think that ME type is not even here. Here it is. Most probably we should have two ME types. That's why it's problematic. Yes, we have two MEE types. So we need to get rid of one of them. In second last also, yes, you find it good, Prakash, thank you. Yes, we need to get rid of one ME type. So just before we go to that, let me check because this ME type is for auxiliary engines and this ME type is for main engines. Let me see what do we calculate later so I can properly. Okay. Yeah, they are supposed to be on the same. They're supposed to be on the same column and not two columns. So probably this was a wrong concatenation somewhere. Because we're filtering out here, ME type AE, ME type AB. And it seems to me that we are actually not using the first one on this one. So I guess it will be safe to just get rid of it. Just a second. Where is this coming from? EFCH. Yes, I changed the name. Ooh. Okay, I will make it safe in a way that I know that it will run, but it's pretty much. So I assume that it's getting an error from before and is suffering on that. Let me run everything again to make sure it's not anything I left behind. No, we just, okay. Let me take this out. So get us through, guys. This is real time. Yes, Prakash, one of the options will be renaming the IME type, but I am not sure whether I have something else that will crash later on. So I rather prefer just to stay just here for a moment to see if it works. If it works, that means that probably was a concatenation that I had to do before. And I actually did before, but after rerunning the boxes over and over again, it might crash. Yeah, what's problematic with merges when you do it over and over again is like it already recognizes what is in there and merges again no matter what. And you might have problems having like same column names afterwards when you rename it. But if you like, sometimes if you like go on a sequence, that shouldn't be a problem. Okay, now it's okay. So that means that if you run it all together from the very beginning, there seems to be a merge that cannot be done twice in one of the boxes. And if you run it from top to bottom, then you should be able to get through. Right? So that means that there's one merge of the several merge that we have done that cannot be run twice. Otherwise, it gets problem. Okay. You see, now I can get problem again. No, it's a different one, but we already have that data. Don't worry. Okay, what happened now? I got to reset it again. Oh my goodness. Yes, I rerun it again and problem again. Okay. But you had the next one? Okay, that's another error. Try to find it. I really want to hit my past me now. I was very excited putting a lot of errors in there and I get too excited perhaps. But I know that that error is a simple one, so don't worry. And the hint is on the top. There you have the column names. So check it out. The hint on the problem on 79 is on the top box at the very end. So at the very end, what we have done is like we have renamed the column. And we have an error here because there's no lat long in here. So what we should do? That's a simple one. Prakash? We're almost finishing, I promise. So I will just jump into the answer. The problem in here is that we are naming the columns, or at least we're trying to find a column with the wrong name. And that is actually one of the most common errors you could have when you're dealing with this. Because there's some standards of people that names this lat long. In our database or the global platform database, by default, this is called latitude, longitude, all together. Okay. We went through this. This works good. So it seems that we already have all the information we need. We calculated the data frame was generated. And the last step for us is pretty much transforming that to something that we could plot. And there comes the me again. Oh my goodness. Yeah, it's CO2G. Not X tons, CO2G. So we can erase CO, X tons, or whatever, and to get it COG. Okay, it went through. We will jump the questions that's for you to answer later on. So we transform whatever data we have, we transform into geodata frames. And then that's very easy forward from then to plot as well. Okay, we have our first plot. Okay. Finally, how many steps do we have to pass, Abdullah? About 20?
Million steps.
Many steps, right? And the problem of this is like, you need to be certain that the steps are done properly, otherwise your results like. So the next time that you see, or perhaps you try coding yourself and you see somebody trying to deal with this, you can have some compassion on the working time and giving instruction on how much time they should bear with this. Okay, so here's the final result. So we had the same map of Dubai and the anchorage out of Dubai. Seems that this vessel was anchored sometime out of Dubai. And this is the amount of CO2 emissions they generated at that time period. Okay? So we can go over CH4 methane and have a separate emission plot. And it might look like this. So if you want to see additional information, I prompt you to go on the link over here. We have a real-time emissions calculator project in Panama. Now what we will see is the prototype. But in a very short period of time, this should be running on a real-time basis, right? So remember, warning, and I have to stress strong on this one. Always remember to stop your Spark sessions. That is good for you, and that is good for the platform and for any other uses. And Alex will be happy not to troubleshoot while your session is not running. And for the environment as well, because then Amazon emit less too. And then we stop the Spark session, and that's pretty much it. Okay. Very good. Last step, but not least, we go to the kernel bottom over here at the very top. And then we shut down. This is also important for data mechanics for not having hanging processes in their side too. Okay. Shut down the kernel. Okay, back, go home.
Thank you. Wait, I don't see it. Okay. Thank you, Gabriel, for this detailed step by step.
I'm sorry, one more step, and
Okay, go
and
ahead.
I promise it's the last one. If you want to find a solution proposal, just type in my name, Gabriel Fuentes.
Just put it in the Zoom.
Yeah, I will put it in the Zoom. Okay. I will put it on Zoom. If you want to find the results working all together. Okay.
Okay. Okay. So Gabriel, thank you for step by step. I know that is a lot to to chew, especially that the background theory behind these calculations,
Yeah.
right? It is quite easy and straightforward to run it, but to understand everything behind it is a lot. Yeah, it took a lot of work. So thank you again for everyone that on site and off site. So I hope that you enjoy our AIS sessions, and all of the informations will be shared, right? So you can repeat again the exercise. The API key will be valid until next week. So you are welcome to try it out. You're also welcome, to share the API key with your friends and colleagues, right? So they can also learn, and they can also follow the recording. So thank you for everyone, and I wish to see you sometime in the future. Bye bye.